There we go. Okay. Welcome, everyone. Today we're going to talk about ZFS Any RAID and the flexible disk layouts that it enable. So what if, I don't need to be quite that loud. So what if we didn't need to have block pointer rewrite in order to have flexible disk layout? Can we make ZFS flexible without making it completely unmanageable and undevelopable? So quickly today, we'll start by introducing myself, and then we'll talk about the shortcomings of RAID Z and what led to designing any RAID in the first place. And then we'll go through the objectives and the implementation with some real-world examples, and then continue through the implementation and summarize and take some questions at the end. So hello, I'm Alan Jude. I'm a FreeBSD and OpenZFS developer and the head of the Solution Architecture department at Clara, where we develop ZFS and FreeBSD. So starting with the shortcomings of RAID Z, why did we want to start this project in the first place? The first is with the RAID Z, when you're laying out a VDEV, the width of the RAID Z stripe is fixed to the number of disks that you have, right? So if you have a 4-disk RAID Z1, your RAID Z width is 4, 3 parity and 1 data. Or if you have 5 disks, then it'll be a width of 5, and so on. And the same is true for RAID Z2 and RAID Z3. It's always going to match the number of disks that you have. Even with the new RAID Z expansion feature that allows you to add another disk. So if you had a 5-wide RAID Z1, with RAID Z expansion, you can add a 6th disk. All of your existing data will still have a width of 5 because it hasn't been rewritten, but anything new you write will use a width of 6. So the RAID Z width always matches the number of disks that you have, which is good for efficiency in most cases, but it can limit your flexibility, and so that's one of the shortcomings that we addressed as part of any RAID. The next thing is the consistent size, right? All the disks that are in the VDEV are treated as the same size, and that size is the smallest member of the VDEV. So if you have a mix of 4 and 6 terabyte drives in your VDEV, we're going to treat all the disks as 4 terabytes, and that excess space on the 6 terabyte drives will be unused. Until maybe some point in the future, if you replace all the 4s with larger drives, and what is the smallest drive changes, then that space will become available. But in the meantime, it is all just lost. RAID Z also uses a dynamic stripe. So if your file is not so big as to need the full width of the stripe, ZFS will make a smaller stripe, which is good for efficiency on the disk. You're not wasting space, especially if you have a really wide RAID Z. But the downside is this makes other parts of ZFS more complicated. If you're looking at doing a scrub or a resilver, we can't just copy data from one disk to another disk because we don't know where one file starts and the next file ends. So scrub has to walk through all the metadata in order to tell where each file starts and ends, whereas if we had more of a fixed stripe width, it'd be easier to tell where those cutoffs were. But because of the efficiency improvements, especially when you use compression in RAID Z, dynamic stripe is a good thing. And the last shortcoming of RAID Z, especially as you get really wide, is limited IOPS scaling. Because if you write a big file and we spread the write across all the disks in your VDEV, it means when you're reading it or writing to it, you have to activate all of the disks except for the parity. The dynamic stripe width hopefully means your parity is distributed across disks so that you can actually get maybe the bandwidth of every disk in your RAID Z. But it means the effective IOPS of your entire VDEV, that entire set of disks, is the IOPS of only one disk, because all of them are moving in sync in order to read the data that we've distributed across those drives. So hence, we have any RAID. The objective here was to improve the efficiency of VDEVs constructed of disks of mixed sizes, while maintaining all of the other features of ZFS. So we have the renowned parity and the fact that losing a disk means your data is still okay. We have the scrubs and the checksums and the compression and the replication and dedupe and all the other features of ZFS still work, but we're trading off maybe a little bit of performance for this extra flexibility and having the ability to get more space out of our mixed set of drives. We also wanted to solve the problem that's common for less enterprise scale users of ZFS, where you don't necessarily have the option to buy disks in sets of a dozen at a time. Maybe you can only add or remove 1 or 2 disks from your pool at a time. So adding the ability to add more disks over time, to upgrade the existing disks with bigger ones, or to be able to actually remove a disk from your VDEV. Only adding is possible with RAID Z, and that's only relatively recently. And as we talked about, it is a more complicated operation that involves reflowing the data and shifting your parity width to the new size. And so one of the things that any RAID enables that isn't possible elsewhere in ZFS is to relocate your existing data to maximize these advantages. Everywhere else in ZFS at the moment, you would need this mythical feature called block pointer rewrite, which has been speculated about, but most of our developers agree that if we implement that, it'll be the last feature in ZFS because building anything else on top of it will be too complicated. So let's look at a couple of real-world examples and see what this can actually do, and then we'll get into how it works. So in our first scenario here, we have 2 4 terabyte drives and then 3 6 terabyte drives mixed together into a RAID Z1. If you use normal RAID Z1 in ZFS today, that'll get you about 14.4 usable terabytes of space. Because you'll treat all 5 drives as if they were just 4 terabytes, and you'll lose 1 to parity, effectively. But if we use any RAID with a Z1:3, meaning the width of the RAID Z is 3 wide, rather than the 5 of the number of disks that we would use otherwise, which actually gives you a slightly worse RAID Z parity ratio. You're going to have more parity for the same amount of data than with the traditional RAID setup. But because we are actually able to use more of the space on those 6 terabyte drives, we actually get 32% more usable storage, about 19 terabytes compared to 14.5. So even with worse parity, because we're able to use that extra space, we're able to get a lot more usable storage. And with that configuration, because we set the stripe width to 3, it's actually possible to remove up to 2 drives from that any RAID, as long as you have enough free space, and be able to shrink that pool if you want to reuse those drives for something else because it turned out you don't actually need that much space. Or in scenario 2, same thing with 2 4 terabyte drives, but maybe we have 6 6 terabyte drives. Right? So we have 8 drives in total, maybe about as much as you can fit in the chassis you have. With traditional RAID Z, you'd get about 24 and a bit terabytes. But with any RAID with a width of 6, again out of the 8 drives, you now get 36.8 terabytes. Basically 50% more space, even though, again, using a worse parity ratio. At this point, it might even be economical to consider doing RAID Z2 so that you can withstand the loss of 2 drives. And even with basically doubling the amount of parity and dropping your efficiency, because you're getting more usable space in the end, it seems like a big win for the trade-off there. And it basically makes it possible to have more parity without losing the usable space that you would have before. So now to the meat of it, how do we actually make that work? So what any RAID does is divide disks up into tiles and assemble those tile sets into stripes. So each disk is broken down into tiles. Currently, that matches the metaslab size. So by default, each tile is 16 gigabytes. And then all the tiles across the VDEV are the same size, and they match the metaslab size. And then we have a tile map that maps each of those 16 gigabyte regions to where it is on disk. By indirecting through this tile map, it allows us to actually decide to relocate a tile to a different physical place, but without the same memory trade-off that the existing device evacuation feature in ZFS has, where it moves individual blocks off of each disk and builds this large in-memory table that can consume many gigabytes of RAM. Whereas the tile map in ZFS here, even with 256 disks in your VDEV, and they're all huge, only takes 64 megabytes. And then we stripe together those tiles to make the RAID Z stripes. So in this diagram, we have a bunch of columns of blocks. Kind of each block is maybe, say, a terabyte for easy math. And each column is effectively one of your hard drives. So we have a big hard drive and a slightly smaller one and a slightly smaller one, and then two small ones at the end. So with any RAID, we currently support either mirroring. So it will just write every block to at least 2 drives and scatter those around, and you'll get a lot more flexibility than you would with normal pairing of mirrors, or maybe make it possible to do 3 wide mirrors. But with the phase 2 that's also out as a pull request, you can do RAID Z 1, 2, or 3 at whatever width you would like. So one of the constraints there is that ZFS must ensure that the stripe for the RAID Z never uses 2 tiles from the same disk. And so that's one of the things we'll do. And then when we're allocating tiles off of this grid of unused space, we attempt to use the largest tile that has, or the largest child that has the most free space first. And you'll see why in a second. And one of the critical things we do is we don't allocate all these tiles up front. We defer that and wait till the last possible second to decide where to put tiles so that we can make the decision that makes the most sense at that time. And by deferring that, it means if other disks show up in the future, we can use them more effectively rather than having to relocate existing tiles to make use of that. So for our first allocation, as we said, this is using RAID Z 1:4. So we need 4 tiles. 1 will be parity and 3 will be data. So we just allocate across 4 disks, starting with the disk that has the most free space. So we have these first 4 tiles. Each of these is 16 gigabytes. So we can allocate a lot of blocks out of those, and we won't need to allocate another set of tiles right away. But eventually, it'll be time to allocate a second one. So we'll start with the disk with the most free space, that 5th column there. But instead of continuing to go across, because there's more free space on the first 3 disks, we will use those to back those first set of tiles. And so again, we use the algorithm of which disk has the most free space and use that to decide where to put the tiles. And then, so for the next one, it switches. We can see, disks 4 and 5 there are the same size. So we're kind of going to alternate back and forth between those as having the most free space, and then use up the biggest disks to back the rest of the stripe. And you can see the same thing, where we're alternating across the 2 disks of the same size, but then the other disks have the most free space. But now, that 3rd disk doesn't have as much free space as the 4th and 5th anymore, so we allocate the tiles this way instead. And then when it comes time for the next set, we finally start using the smallest drives, because their amount of free space now makes them the candidate with the most free space. And then we can continue doing that as we start filling up those drives and using up the smaller disks. So I did a whole bunch here to kind of avoid getting too far into it. But this is why we wait as long as possible to start allocating the tiles, so that if we add another disk on the end here, we would start using it right away. And we don't run into the problem we'll have here where eventually, if we put everything on the biggest disk first, we'd have only the small disks left, and we wouldn't be able to make a stripe that's 4 wide where all 4 tiles are on different disks to maintain the requirement that if we lose a disk, we still have enough parity to reconstruct everything. And so we maintain the reliability that we've always had. So now if we look at disk 4 here that I've kind of outlined in red, if that disk were to fail, as we can see, we have only 1 block of any one color. And so we'll be able to reconstruct, for example, the yellow stripe that uses disk 1, 3, 4, and 5. If we lose disk 4, we'll be able to use the parity and reconstruct that block and put it somewhere else, or the replacement for disk 4. So that preserves all the requirements to make RAID-Z work, and we can be happy there. And if we had chosen to use RAID-Z2 here, we'd be able to do it even with losing 2 disks. Again, because we're ensuring that no 2 blocks of the same color are ever on one hard drive. I don't know if that's quite big enough to see, but I've kind of labeled each of these blocks so that we can kind of talk about them a little bit. But with the tile mapping, we now have a logical to physical mapping. Right? So this tile maps off to the side, storing, I know that stripe 0 block 1, or tile 1, is on disk 1 at this offset. And it allows us to decide to move that. So if we're going to remove a disk, or if we just need to relocate some blocks in order to more effectively use the free space, we can do that. And this simple conversion allows us to do a quick lookup, when we're running the I/O through ZFS at the ZIO layer. We can apply our custom layout and know where the data is on disk, and not have a complicated procedure like DRAID. And then this continually gets extended as we allocate more tiles, but we defer that to avoid needing to rebalance, which is one of the capabilities we're about to talk about.
Question.
Yes.
Yeah.
Oh, is it not on now?
Just repeat it.
Nope. White?
I'm Mike. Hello.
There.
Just curious, maybe you talked about when exactly are those tiles allocated?
Basically, when the other ones are full and ZFS goes and starts using a different metaslab, as it goes to write data to, when it goes to allocate data, if all the existing ones are full, then it'll allocate the next one.
Okay. So you can kind of think of it as a really good SMR type thing.
Not related to SMR, but we'll talk about SMR more later.
Okay.
So ZFS probably won't fill every one of these blocks before starting the next one, but once they're about 80% full, they're usually pretty fragmented, and it makes sense to start going to the next one instead. So it doesn't wait till they're completely full, but we try to avoid using a little bit of every tile before we go back and fill up the rest of it, to avoid losing the flexibility that we're going to talk about in a second. Any other questions at this time? No? Okay. So on to the really interesting things we can do with this other than get more usable space. So expansion. We can easily add a new member to the VDEV. So if we add a new big disk on the end here, we're not going to change the parity width, right? The RAID-Z is going to stay at our size of 4 wide. Unlike with RAID-Z expansion, if you added this disk, it would actually expand the RAID width for all new blocks to the full width of the new size. So you're not going to get an improved parity ratio, but as a trade-off, you'll gain the ability or retain the ability to shrink this VDEV, which we'll talk about in a second. So if we just naively try to use this new disk, we can see in the kind of highlighted in yellow, we'll write the first new block to disk 1, 2, 3, and 8. And then for the green one, we'll do another set like that, and so on. But when we try to allocate the third set of tiles, there's only 2 different disks that we can distribute across. So in total, we were only able to use 2 of the 10 new terabytes that we added, because this pool was so full when we decided to expand it. If we had expanded it earlier, where, say, the dark blue, brown, and the pinkish blocks weren't there, we would have been able to use a lot more space. And that's why we defer allocating those tiles as long as we can, to avoid having to do this next feature, the rebalance. So since we'd only be able to use 2 of the 10 terabytes of this new disk because we couldn't find enough other places to put data to keep the parity, we can instead do a rebalance. So we can pull data off of a bunch of different disks and shove it over to our new 10 terabyte disk. And then because we did that, we can now actually create 4 new sets of tiles. So we have 4 more usable terabytes than we would have before. But we still have, you can see, 3 white squares. We have this orphan bit of space because we don't have a 4th different disk with a free terabyte in order to put a tile on. But if we add another disk in the future, we'll then be able to gain that. But by having this rebalance, we ensure that we get to use like all of this new disk instead of only 10 or 20% of it. But we can also do the opposite. We can contract the pool. Simon?
Is there a tool to visualize that?
Yes. So in ZDB, the ZFS debugger, there is a tool that can visualize how the any RAID is laid out. Because, yeah, it gets hard to reason. Like even here, I've kind of pretended each tile is a whole terabyte, when actually they're 16 gigs at a time, so you're going to have a lot more tiles than this. Yeah, we added that. Also, another feature we did kind of unrelated to this in ZDB is the ability to just inspect how any RAID Z data is laid out across the disk. So even if you're using traditional RAID Z, being able to look at how it laid the data out and like where it put the parity versus the data, especially for a file that's more than 1 stripe, is very interesting to be able to inspect that. The ASCII art is not perfect, but it's the closest we can do. You might need a bigger terminal window if your RAID Z is really wide. So with contraction, we can decide to take a disk out of this AnyRAID. And to do that, we will effectively find, I have blocks 0, 1, 2, and 3. You notice the white blocks that are not allocated, we don't have to do anything for. So I just put an X through those. But 0, 1, 2, and 3, we can just relocate to other disks. But we have to make sure that as we do that, we don't put, for example, a red block on another disk that already has a red block. So after we move the stuff and ensure that we didn't get any disk with 2 blocks of the same color, it is now safe to remove that disk because it doesn't contain any data. And this is only possible because we have that tile map that allows us to adjust where tile X, Y actually is without having to change ZFS's logical view of the data, right? The block pointer still says, it's at this logical offset in the RAID Z VDEV, or in the AnyRAID VDEV. We just change where that is under the hood. Can we get the white mic, please?
I assume, is it on?
Yep.
Okay. I assume if a disk fails, you are automatically doing this contraction process to automatically, you're reconstructing, but then you would do the same thing in terms of making sure you're using the available space on other disks automatically, rather than just saying, hey, we lost a disk, please give us a new disk.
So actually, it doesn't contract automatically. It will be able to reconstruct the blocks in memory from parity as you need them, and then you would normally replace the disk with another one. But you can choose to do the contraction either before or after the failure.
I would suggest it would be good to automatically start doing a contraction, because you don't know how long it's going to be before somebody replaces a disk, and if they have another disk fail, then you're in trouble if you haven't already done the contraction.
Yes, although if you have a spare disk that you're going to do right away, you wouldn't want to waste all the I/O copying the data somewhere else to then decide to move it back to another place. But probably at least an option to automatically kind of do the distributed spare kind of thing like DRAID does would make sense, yeah.
Okay.
And actually, one of the features we identified is that if you have a disk that hasn't failed yet, but it's starting to act up, you might decide to preemptively contract your pool because this is your home lab, and you know that it's going to, with the price of disks today, it's going to take you a few months to save up enough money to buy that replacement disk. So contracting even before the disk fails, just because it's old or the smart data says it's failing, might actually give you some additional flexibility there and ensure you don't endanger your data, especially if you're only using a RAID Z1, and so you can only handle one concurrent failure. So now we can talk about some of the limitations to RAID Z. So right now, each RAID Z VDEV is limited to 256 disks, although I wouldn't recommend anybody go anywhere near that wide. But technically, I think in RAID Z, the limit of disks per VDEV is like 64 bits or something. You can have a lot more disks than that in a normal RAID Z, but we wouldn't recommend that. And we're limited to 65,000 tiles in a VDEV. And the limitation of that is how much space we reserve for the tile map. Because we decided the tile map was statically 64 megabytes, we can only handle that many tiles where we're kind of keeping track of the locations for those. With the default 16 gigabyte tile, that's still a petabyte VDEV, so you're probably okay. And if you start with a pool that's anywhere near that big, the metaslab size is likely going to bump up to 32 gigabytes. And so now you can easily do 2 petabytes. So unless you're starting with a minuscule pool and growing it to a petabyte, this limitation is not likely to be an issue for you. Because right now we have a dedicated space for the tile map. So we actually, normally in RAID Z, the data starts being written 4 megabytes into the disk, right? We reserve the first 4 megabytes for the label. With any RAID, we push the data back another 64 megabytes in order to keep this tile map. Actually, I think it's 256 megabytes because we keep 4 copies of the tile map. But we kind of push the data back at the beginning of the VDEV. But because that's a static allocation, we don't really have the ability to make that size bigger in the future. Right? Once you've created the VDEV, that's going to be the size that it is. Don't trip over a cable, that'll knock everything offline.
Yeah, I'm such a troublemaker and like making him
Dexter
dance
back
on my
and forth?
strings. Dance my puppet. Anyway, now that that is out of the way, what implications are there for reading the drives that have, or pools that have had this happen to it? Do we need bootloader changes to understand the new format is kind of where I'm heading with this.
Yes, there would need to be bootloader changes in order to read the tile map and find out where physically that block is when you're doing the logical to physical translation at the ZIO layer. We specifically made it so that you can, this data is at a fixed offset so you can read the tile map without having to import the pool. So you don't have to have access to the MOS to be able to do it because the MOS is actually going to be indirected through this table. So there will need to be some bootloader changes to our kind of mini implementation of ZFS.
Okay, so are you planning on doing those?
I hadn't thought of them until just now. But yes, I guess I will,
always
I will
think
make
about
Paul
stuff
do
like
that.
this. Thanks for adding it to your plan.
Yeah.
Can you have more than one, like
Any RAID
some
VDEV?
mirror and then some RAID Z, like on the same tile map?
So not on the same tile map, but you can have 2 different any RAID VDEVs. And each of them can have 256 disks, and each of them has their own tile map. So you can have an any RAID of mirrors and an any RAID of RAID Z in the same pool, and they would each have their own separate tile map because it's stored on the disks that are members of it. And so the tile map will be, you'll have a separate 64 megabyte tile map for each different any RAID VDEV.
But you can't mix and match.
Inside the same VDEV, no. But you can have 2 VDEVs and have very different configurations if you wish. So again, because of that tile map limitation, the disks that you add in the future can't be more than 1024 times larger than the disks you started with, which might be a problem in the future. Mostly likely this is a problem for a VM where you might grow the disk. You know, you start with like a 10 gigabyte disk and then you try to grow it to many, many terabytes or something. But yes, the size of your future largest disk can't be 1024 times larger than the smallest disk you started with. Just because when we size the tiles based on the metaslab when you start the VDEV, you'll run into the 65,000 limit very quickly there. And then with the contraction, the minimum you can go down to is your RAID Z stripe width. Right? So if you used an any RAID Z1:4, like we did in the graphical examples there, and you had 6 disks, you could remove up to 2, but you can't remove any more because there would be no way for us to ensure that each of the 4 tiles was on a different physical disk. But even if you grew it up to 10, you could still shrink it down to 4 as long as you had enough free space.
Can you add a new disk which is smaller than your original disk?
I think so. You should be able to, yes. It's just the metaslab size is going to already have been set there because all of them have to have the same size. So yes, that would be fine. There are some limitations to contraction. We can only contract when when we have these white spaces to write data to. If we've allocated all the tiles, but each of them is only maybe 10% full or something because you deleted a lot of data to try to make room to do the contraction, but the data happen to be distributed in a way where all these tiles are still partially used and aren't actually free, then you wouldn't actually be able to contract currently. A future possible implementation would be to use the device evacuation feature, which is the existing way to remove a VDEV as long as it's not a RAID Z in ZFS that uses a memory table to remap the individual block ranges. But it's very inefficient in memory because you're basically having an indirection table forever for every block. But if each of these tiles is almost empty, if we could even just free up a couple of them by relocating that data at a smaller granularity than a whole tile, then it might be possible to actually get more free space, but that is not currently implemented.
Thank you. On that problem, I've often thought that like ZFS defaults to looking for the most empty space. And so if you recopy stuff, it tends to defragment a bit. Mm-hmm. If you could have a toggle to say use the most full spot, you might be able to, in this case, for instance, clear blocks.
So the Metaslab sorting algorithms are more complicated now. We actually have a review out unrelated to any RAID that by default right now, if you're trying to allocate a 16 megabyte record on a RAID Z3, which takes about 21 megabytes of space, we will sort all the metaslabs by who has the most, the largest contiguous chunk of free space. So we'll find some metaslab that has enough room to service that one allocation. And then it might turn out that that was the only big chunk of free space in that metaslab, and we have to now unload that metaslab and find a different one to do a second write. So we added a newer algorithm that looks for which metaslab is actually going to let us make the most progress. So maybe it doesn't have as big of a chunk of free space as that one that would normally sort best, but the second best one could do 10 allocations before we had to unload it. So it'll be much more efficient to use that one. So that's a different change on how ZFS decides where to put space. And then Alexander also recently did a feature for the write throttle that's smarter about deciding where to put data. Especially if some of your disks are faster than the other disks, it will try to balance the writes when the system's not fully busy. But if you're starting to struggle to keep up, it'll start using the faster disks more. So in the pull request, there's some great examples of a mix of SSDs and hard drives. And just because they're faster, don't fill all the SSDs first. You try to save their space for when the system's writing as fast as it can. And using the SSDs will be the most advantage then. One of the other limitations is that the trim and initialize, which is a way of going and writing an initial pattern over the disk, is meant to defeat thin provisioning, don't work on the unallocated tiles. So because we defer creating the tiles, when you try to trim the space, if it's an unallocated tile, we just skip it because we haven't decided what disk that actually is yet. And so trim doesn't actually write to those drives.
Yes, I understood that obviously there is no mapping to do that. Mm-hmm. But I was thinking in slightly different context of SMR drives or just general SSDs that may have a lot of translation from previous life of the drive during a drive addition. Maybe we could do it more regular part of drive adding routine, like pre-trimmed on addition.
We already have trim on it as a tunable, right?
But I'm not sure it's enabled to something.
It's not enabled by default because I remember in the FreeBSD installer, it would make the installer just hang for an hour while it went and trimmed all the drives. But yeah, maybe for any RAID, it would make sense to have that kind of enabled by default.
On any RAID, either for all disk or maybe during when you are
Specifically when you're adding it, yeah.
Yeah, no, for SSD, I guess would be better to wipe it all at once.
Yeah.
But
I guess you're saying trim before we allocate the tile to it, maybe.
No, either for each individual tile or when adding a disk first at the beginning.
Yeah, I think when adding the disk would be a good time to do it all, and then we don't have to worry about the fact that we're not doing the trims as we go because we did them to start with, yeah.
I just wonder what part of our problems with SMR drives receiver goes from points that we don't trim on addition, on replace. Maybe would we trim on replace, they would have empty map and would write happier.
Happier, yeah. That's a good point. So looking at ways we could remove some of these limitations, obviously for the number of drive limit, the tile limit, and the biggest drive you can add based on the smallest drive you started with, we just need a way to increase the size or handle the mapping limit better. So with the separate work that Clara is doing on changing the label format and making the label bigger, we might be able to dynamically allocate a larger tile map that way and have that within the label space rather than within the data space of the VDEV. So it might be possible to have a larger tile map. Rather than doing that for the purpose of having even more drives than that in one thing, it might in the future allow you to have a smaller tile size that would give you even more flexibility. But dealing with a tile or a metaslab that spans multiple tiles gets really complicated. So for now, we fixed the tile size to match the metaslab size. And the metaslab is the on-disk format that ZFS uses to keep track of what space is allocated and what space is free. We could compress the tile map. Currently, it's a static 64 megabytes. Compressing it might make us able to fit a larger one, although because the compression would be variable, we would never want to be in, like it fit, and then we allocated a tile and now it doesn't fit in the space, that would be a problem. Another thing we could do in the future is RAID Z expansion within an any RAID. If you're up to 10 disks and your tile width is still 4, that's pretty inefficient, and you're probably never going to remove enough disks to get down to that size. So being able to use RAID Z expansion to basically increase the width of your tiles once you've added enough disks could be a good win to, again, increase the efficiency of the RAID Z for all your new writes. And then the one I touched on a little bit earlier, when we have a tile that's mostly empty, if we could maybe use the device removal code to remap just a few blocks in order to completely deallocate a tile, that could give us a lot more flexibility. We also have some future ideas. Right now, because of the way we're doing it, we're not, unlike in a normal RAID Z, doing a read isn't necessarily going to activate every disk. Right? If we go back to, a pool that's not very full, if we're reading that dark red block or set of data at the top there, we're only going to use 4 of our 7 disks, and the other 3 are just going to be idle. And then if the other data happens to be on the yellow tiles, again, we're only using 5 of the 7 disks, and a bunch of that space is going to be sitting idle. Once your pool is reasonably full, any read's probably going to activate most of the disks, and it's not going to make that big of a difference. But there may be things we could tweak to better use this space, or even just when deciding how to write a file or where to write a file, to spread it out a bit more to be able to get more of the available bandwidth of all of your disks. But the primary use case for any RAID is getting as much storage as possible, not getting as much performance as possible. If you have performance requirements, maybe you should build a pool designed for that, rather than this pool that's designed for flexibility and maximum storage rather than performance.
In this economy?
Yes, in this economy. And then one thing we'd like to possibly have in the future is the ability to convert an existing RAID Z into an any RAID. You would be stuck at that higher stripe width size, but it does mean if you added drives, you could slowly kind of manage to relocate data around and get more of the flexibility from any RAID. At the moment, this would also require getting the tile map into the label instead of into the static space at the beginning of the drive, because that space currently would be used by data in the pool. But it may be a thing in the future to be able to convert an existing pool to using this. But I don't know how much demand there is for that. We've also, when we presented early work on this at the ZFS Developer Summit back in October, approached by Seagate with an interesting use case for this. Newer enterprise drives, I think 28 terabytes and above, have this concept of an element failure. So a hard drive is made up of a bunch of platters with kind of heads on both sides. And usually when a drive is failing, it's one particular head that's the problem. So if you have a 20 terabyte drive, that might only be taking out 2 terabytes of your usable space. And so these drives have two options. They can reformat themselves and come back as an 18 terabyte drive, and it stops using that one head, but it erases all the data that's on the drive when you do that. But the second option they have is just to communicate with the operating system and say, these are the list of block ranges that are not accessible anymore because that head is broken. And if we were doing, if the data on there was already in any RAID, we could remap those tiles, if they happen to align, to a spare. And so now that spare is only 2 out of the 20 terabytes. And it means that if another drive had the same problem, maybe we could move its tiles and basically have a composite spare that was replacing the failed components of a bunch of other drives. But we'd have to constrain that to the existing rule of, we can't have 2 blocks of the same color on the same drive, especially that spare. So maybe you'd need a couple of spares, but depending on how big your pool is, this could be a more flexible way for ZFS to deal with hard drives that kind of, at a small scale, fail in place. Right? We lose one particular head out of the 10 or 20 heads in the drive, and just relocate that data in a way that ZFS would support without rewrite. NVMEs are also getting this same feature, although it works slightly different because the protocol is different. But to be able to communicate that this flash shell is worn out, you're not going to be able to use it anymore. Most of the time, the drive's going to take care of that with its spare cells under the hood with the firmware. But as we get to drives where it's maybe more host managed on the flash side as well, this could also be interesting. Again, I found it interesting that a feature design almost specifically for home lab ended up having enterprise applications. So the key points of any RAID are, gaining flexibility while maintaining reliability. We're maximizing the amount of usable space. We're gaining the ability to expand and contract our RAID Z a lot more flexibly than we can today. We have the option of mirrors and RAID Z2, or RAID Z 1, 2, and 3, actually. Maintaining compatibility with all the existing ZFS features, so dedupe, block cloning, send and receive, snapshots, checksums, compression, all of that just works with this. And using this to achieve the lowest possible cost per terabyte, which, as people said, in this economy is especially important with the price of disks continuing to climb and having that ability, not necessarily being able to predict how quickly you'll be able to source a spare. We've seen lead times of 6 to 14 weeks to buy a hard drive. Especially if you're trying to, at enterprise, buy larger drives or whatever. It's not like you can go to Newegg and order the drive and it comes tomorrow.
Only 14 weeks.
And vendors doing instead of a replacement, just sending you your money because they make more money with that disk they get.
Yes, and that's another thing Michael pointed out. A number of vendors have started, if you try to warranty a failed drive, they will pay you back what you paid for the drive rather than a replacement drive, because the replacement drive is twice as much money now. And some will even apply a 15% restocking fee for the failed drive. which is, especially bad. And Warner commented that, yeah, even Netflix has 14-week wait time to get new drives.
14 weeks would be fabulous.
Yes, it would fabulous, exactly. You see, 14 weeks is a good thing. So knowing that, getting spare drives might not actually be that practical anymore. And knowing that, being able to contract and be able to, as Colin mentioned, get back to being able to lose another drive in the meantime can be a really big thing when, you can't predict how long it's going to be before you can replace that failed drive. So specifically, I'd like to thank the whole team at Clara for helping with this, especially Paul, who did a lot of the work based on my design, Eshtec and HexOS for sponsoring it, and the OpenZFS community for being great to work with, specifically Brian Bellendorf, Alexander Moten, Tony Hutter, and Alec Pinchek for the review so far. Colin?
Have you talked to cloud vendors about this? I'm thinking of the case of somebody spins up a virtual machine in a cloud, they set a certain amount of disk space, and then that fills up, and expanding a disk may be an option. In some places you can expand the size of your volume and then expand the file system within it, but it may add more flexibility doing this approach, because then they would be able to shrink later on by dropping other. If they start out with, say, their data is spread over 4 disks, they can add a bigger disk if they need to, but then if they decide to go back to a small amount of storage, they can drop the bigger disk, go back to a small set of small disks, something like that.
That would definitely be interesting. I think looking at it that way of, from the beginning, I'm going to actually make my cloud thing 4 disks, not 1, even if they're add up to the same amount of space. We have seen people in certain clouds, like the Akamai one, each disk is IOP limited. So if you just use 4 disks and stripe across them, you get more IOPS for the same price.
Yeah, we should talk about this.
Yeah, and I think maybe even just writing some best practices. Like, this is mostly something that somebody could implement themselves, but writing out the best practices for it could be very interesting. Well, the mic moves around. I'll also be doing a webinar about AnyRAID where we'll be taking more questions on the Thursday next week at 11 a.m. Eastern. So if you're interested, grab that QR code and come join us for a live webinar. We'll be answering more questions about this, especially on the home lab side with John Pinozzo of HexOS.
Alan.
Yep.
Given the premise was mostly home labbing, but you're seeing enterprise opportunities or benefits here, given time and maturity, do you ever see this perhaps becoming the normal or default way of creating pools, given the flexibility and most of the trade-offs going away?
Possibly. I think the performance trade-off is likely not worth it in most, like, if you have 20 or more disks, it's probably, you can handle it a little easier, but yeah, it's likely that it has enough advantages that it might be a default for a lot of cases.
So Warner asked the bootloader question. Mm-hmm. How about the installer?
The installer, that's just a couple lines of shell script to add AnyRAID, so that would be good.
Yep. Yeah. And I guess the other question I had was, I was thinking it's probably a little difficult to reason about. I have this collection of disks, which RAID should I use on it in this configuration? Do you have a tool to visualize or tell me what would happen if I did this?
It's on our to-do list to make a calculator on our website for this, because both just to compare, is it worth doing it over a RAID Z for the slight performance trade-off or whatever, or I have these, recommend the best layout, or show me my 3 options and I can decide which, how much I might, if I have 6 disks, do I want to set my stripe width to 4 so I can remove 2 disks, or do I want to set it to 5 or 6 because I know I'm never going to need less space, and this will give me a higher RAID efficiency and so on.
Yeah.
So yeah.
Okay, cool.
Benedict? Also, if you would like help designing your storage, whether it's with AnyRAID or anything else, Clara offers that as a service. Benedict?
Do you have any numbers for zpool scrub? Is that faster? Does it take longer?
not faster because you're going to be reading from fewer disks, but probably not substantially longer because of the sorted scrub feature in ZFS. But no, we don't have a benchmark of that so far. But it would not be better. It's just hopefully not, much worse. Again, it's a trade-off for that flexibility. You're going through indirection no matter what. That just by constraining the size of the indirection compared to device evacuation, it means that every time you run zpool status, you don't get this nagging message about how you're wasting gigabytes of RAM on a remapping table. Yep.
I know you touched on hotspotting a little bit earlier on, but have you done enough testing with this to see whether that first disk is going to get nailed most of the time? And I'm just thinking like disaster cases when you're on edge case or you've got multiple failed disks or you're, because in theory your smaller disks will be slower.
Yeah, and it's also like in most people's configuration, it's probably the smaller disk will be the one at the front, and the big disk will be the one at the end, because when you add disks, they're usually bigger than the disk you started with. So likely your thing will be the other way around, but it wouldn't make a difference for how we allocate the disks. So yes, I expect if you have one disk that is significantly larger than the others, it will be a hotspot. But it probably has a higher throughput rate than the smaller disks anyway. But there might be some things we could do to try to mitigate that a little bit, especially when there's a tie, instead of putting everything on the biggest disk, maybe we spread it out a little bit more. Or tuned by latency. Yeah, or tuned by latency, although Mav's right throttle rework said there are downsides to tuning by latency in that the biggest disk might be the lowest latency, and then we fill it up first, and then we can't get enough matches anymore.
Same problem.
Yeah. Any more questions? All right. All right. Thank you, everyone.
Good to go? Okay, good morning, everyone. I'm here to talk about building products with NetBSD Part 2. You might say, why Part 2? That's because I talked about Part 1 17 years ago at this conference. So it's good to be back. My background is that I was an Acorn computer user for many, many years, back since the BBC B, so we're talking 83. I then worked for Acorn Computers for a while, and a company called Exemplar, which was a joint venture company between Acorn Education and Apple's UK education, solely responsible for selling all Acorn and Apple hardware into UK schools, from 96 when it was founded. Until 99, and then in 99 I set up my own company to carry on the work I'd been doing at Exemplar, and I've been an NetBSD and package source developer since 2007. So I first encountered Unix-type operating systems back in 93 on some bizarre old hardware while I was doing my PhD in psychoacoustics. And then pretty soon afterwards, we got some SGIs, and those were very cool because they had graphics and things. And so as part of that, I learned C and shell programming and all those sort of things. I was only a standard user, but it was a very small lab, so I could soon discuss how the rest of the system worked with the people who were actually in charge of it. Now, a little bit of history here. So the Acorn Archimedes was released in June 87 to the ARM2 processor. So this was the first commercial desktop that was using an ARM processor. It's an 800K floppy, optionally a hard drive, but back like nowadays, no one could afford them. And it could only address 4 megabytes of RAM because the memory controller was hardwired to support a maximum of 4 megs. A little bit later on in 91, the A5000 was released. This had an ARM3, so it's quite a lot faster. The other one was an 8 megahertz. And this had an IDE hard drive. So we were getting a bit more standard in terms of storage, and its chipset was also a little bit more I/O-like. Came with a larger floppy drive, so that was good. And you could optionally have a second MEMC, so you could have 8 megs of RAM. But then the big deal in 1994 is that the RISC-PC was released, and so this was a significant change in that it was very expandable, so you could actually have multiple CPUs in it, and they didn't have to be the same type of CPU, so you could have an Intel CPU and an ARM one, so you could run Windows on this thing. It could have a lot more RAM, and because of its expansion, you could put in more expansion cards, so you could put in SCSI, multiple network cards, all sorts of things like that, and there was DMA on some of those, so it was starting to get better performance. The big difference is that the ARM 610 processor this came with supported 32-bit mode. The previous versions of ARMs were only 26-bit, which meant that obviously the amount of memory and things you could address was much greater with the newer hardware. And then in 94, I managed to get one of these. I was a student. But as a friend of mine was doing summer work at Acorn, so he was too hard up, so I managed to take advantage of his staff discount. And of course, I'd started to learn about Unix while I was doing my PhD. I was thinking, well, okay, let's see what I can achieve with my RISC-PC. Now, a little bit of a segue here. Acorn themselves actually did have a BSD Unix that they released commercially. Back in 1989 was the first release of this. And this was back in the days when you had to buy licenses. So it was £1,000 for the license of RISC-X. If you wanted the workstation, it was nearly £4,000. I do have working machines. That is a D message, and that's as much as it is. It's basically, yes, you've got a SCSI drive, you've got a network card, and you've got a processor, and that was about it. So back to the story here. In 1994, there was a post on the Comsys Acorn newsgroup saying about RISC-BSD is going to be bringing an ARM-based Unix onto the RISC-PC platform. Now, if you remember, I said there's two different sort of eras of hardware here. There's the RISC-PC, which was 32-bit, and then there was the older ones, which had very limited RAM and so on and so forth. Now, but also the RISC-PC, as I also alluded to, was quite expensive, certainly for students who were the sort of people who had free time to hack on this stuff. So the RISC-BSD people said they were going to concentrate on the RISC PC because it clearly was the best bit of, the most suitable hardware for the task. And they said they were probably going to go with NetBSD. That post was then followed up with a competing project saying, no, you want to use the ArcBSD project, and we're going to probably use straight out-and-out BSD 4.4 code. We're not going to bother with all this NetBSD, FreeBSD stuff, but we're going to start with the older type of machines. At some stage, we might get it working on RISC PCs, but we're not in that position at the moment. And then just to complete this, around the same sort of time as well, a single student in Southampton decided he was going to start working on potting Linux. And this was a single-man project. He was a student. And this was very much on the older computers. So if we move forward a couple of months, October 1994, there was someone tried to give a bit of a summary. It's mainly wrong because it was getting FreeBSD and NetBSD mixed up. And so this guy called Gary Palmer was at the time, I don't know if he's still around in the community, but he was a FreeBSD core member. So he clarified this, basically saying, yes, we've got ArcBSD, which has now acquired an H in its name, is going to be using FreeBSD, and the RISC-BSD people are going to be using NetBSD, and we've gone with FreeBSD because of licensing stuff, and it turned out that actually all the code had been nicked, and so it was better to actually just use FreeBSD. And so if we sort of look forward now, how this actually ended up, RISC-BSD then became NetBSD, the Acorn 32 port. It was always targeting the RISC PC in 32-bit mode. It had quite a big development team. It started with 4 core people. The ArcBSD, that never came to light, never got released. And it was only ever targeting the old hardware. And Linux did get released, was used, but no longer supports Acorn. But so NetBSD still supports this hardware. But the other ones never saw the light of day. And so my decision was obvious here. I had a RISC PC. I was going to use the one that was most available. So I downloaded this onto many, many floppies, over a 9600 baud serial. Got myself a larger hard drive. And of course, this meant I had root access. And I could connect to the 10base2 network in my lab. But I decided that academia wasn't really the future for me. So I got a job working for Acorn, which then quickly morphed into working for this company called Exemplar. And then the big change for me is that in 1996, the Acorn NetStation was released. So this was an implementation they were asked to do by Oracle of a reference design for a network computer. This was available with either Ethernet or a modem. The idea is you could get this and you plug it into your TV and plug it into your phone socket. And it had a built-in web browser. You could do email and a basic word processor and things like that. Now, we were given 2 of these, and nobody knew what to do with them. But I had a spare RISC PC, and I knew about RISC-BSD, which was now, by this stage, was called NetBSD, ARM32 port. And so I wrote RISC OS. RISC OS is the operating system that Acorn uses, which booted over NFS. And we demonstrated this to the public in 1997 at the biggest educational technology show in Europe, at Olympia. And so we made this into a product. This was a RISC PC running NetBSD. It had the boot sequence to allow the network computers to boot. It had things like Apache to give you a web-based user interface, standard stuff like Samba and DNS and things like that. It had a web-based administration and web-based email clients. And this then built up. So we had the whole ecosystem with the clients. We had the internet connections. We had software which we developed, which was an integrated productivity suite, word processors, spreadsheets, all that sort of stuff. And then also, I became Citrix certified, so we could do access onto Windows virtual desktops on this hardware as well to give us a full system. And we had some big sales all around the UK in 1998. There's some example prices there. These all included installation, training, and crucially, annual support. And we sold all these throughout the UK. There's a lot of installs in summer '98. We had all sorts of marketing was done. There's a few examples over there if anyone wants to take a look later. You could even get them by connecting supermarket vouchers. It was many, many thousands, tens of thousands of vouchers you had to get one of these. And so I don't think anybody actually ever did. They maybe at best got a calculator or pencil or something. But it was an interesting concept. And as I say, this had a web-based user interface mainly. So you logged in through a web page, and you logged in and you got a web-based user interface, and we had various learning resources on there. But unfortunately, all things come to an end, and in January '99, Acorn was really not doing very well, and so it sold its stake in Exemplar, its 50%, and it sold it to Apple, which of course meant that Apple owned 100%, which meant that I was made redundant, along with everybody in tech support. But if you remember, in summer '98, we'd just sold annual support contracts. And then within 9 months, they'd made anybody who could do that support redundant. So what was going to happen? So I founded my company in '99, started trading in April. I called it Precedence Technologies, named after the precedence effect in psychoacoustics. And you can look it up on Wikipedia if you care. And so I was contracted by Exemplar for 12 months to provide this ongoing support that they'd already sold to the customers. And crucially, Apple didn't care about any of this. They're basically going, just have all the source code, just have everything. We don't care. We don't know any of that old esoteric stuff. So it meant I could hit the ground running because I had customers. Exemplar had a whole bunch of network computers that was sat in their warehouse they wanted to get rid of. So purchase order number 1 was to just buy all their remaining stock, and then just easily just chop out the logos, put my own logos in place as an example of a children's diagram I saw at a school where they'd done a little drawing of our logos. But it was very apparent by this stage that the Net Manager, based on the RISC PC, was very slow. It's only at 10 meg Ethernet. If you're using its onboard IDE, didn't do DMA. It was clearly going to be a dead product, not least because Acorn were doing so poorly. So some of the original RISC-BSD developers worked with a ARM design consultancy to develop a thing called the CATS. So that's had NetBSD support from the ground up. And so that's a standard PC form factor motherboard with PCI slots, so it was very easy to drop in, 100 meg network cards at that time. But even then, this wasn't not necessarily going to be the future. It was time to start switching to x86. So in 2000, that's what we started to do. And so we took our adverts in the relevant media, relevant media being things like Acorn User Magazine. It was quite, small readership. In 2001, I took on my first employee, and there was too much legacy in the way things had been done. And I thought, okay, let's do the job properly this time. Let's redesign it, call it Net Manager Next Generation. Let's move all the configuration centrally, and that's given us a modular basis to continue development since then. And so this ongoing product, you can manage it through the CLI, or we have web admin now. I did a version of this presentation at your BSDCan last year, and I had to change out this slide because we've now reskinned the web admin. So there's various different admin interfaces, a few little screenshots here of things to do mail aliases and firewalling and setting your time servers. Why would anyone want to use this thing? So our idea is that this is a bit of a Swiss Army knife. It'll do. There will be some purpose to which that it can do for you. There will be some benefit you can get from it, even if most of it you don't need. And so, for instance, you might want cross-platform file serving. So this thing would serve to Acorn computers using their own native methods as well as PCs and Macs. And also we have a web-based access to those same file stores. We used to do things like fax sending and reception, VoIP, and we've been adding newer things as time goes on, so sort of CalDAV and things like that for shared calendars. And it's always been doing web serving because, as I say, the user interface has always been web-based. And so there's a little bit of example here. These are the sort of, the software products that we're using to deliver these relevant services. Because historically we've had a strong presence in the school market, then things like web filtering and security are a big deal. So we've always focused on that a lot in terms of things like doing SSL interception, so we can do content filtering on HTTPS pages. We maintain block lists, which we distribute around the customers, and doing transparent user authentication. So if you've got Active Directory, the users are automatically authenticated, which then means you can get detailed web analysis, and you can drill down into who's been looking at what. It'll do email alerts, so if pupils have been looking at things they shouldn't be looking at, it can email the safeguarding officer telling them that this has happened. I said about the web-based access to file stores, then that's a thing we did as a project when the customers came up and said that would be a good idea. So the architecture of the Net Manager is based on just a basic install of whichever NetBSD release we wish to be choosing at this time. And it's modular, so we can put features on top of this. We use a curated set of packages, so end users aren't free to just stick their own bits of software on it. They can do, but on an upgrade, it will go through and rationalize the set of packages that are installed. So if you do install your own packages, they'll get thrown out till the next time you do an upgrade. We use a thing we call build scripts to actually configure the system, which I'll go into a little bit later. And then we have many custom tools that we've written either as scripts or there might be C utilities to do all sorts of management of all sorts of things like SSL certificates and so on like that. So most things are written in shell script. So there's some PHP, some C, and the web admin itself is all written in PHP. So I was saying we have these scripts. We've got lots of tools in there. So because this is designed to be integrated with other systems, most of which in schools are probably going to be Windows, then this will integrate well with Active Directory to synchronize users and do password synchronization and generation. So it can go and reset all your passwords for a group in Active Directory, for instance. It's used a lot for backups, and so we use rsync for that. And then what that will do is that will pull in data from other servers. And so we have an agent you can install on your various Windows servers, and that will then make that data available for the Net Manager to pull in. So the idea is that the only thing that's getting the data onto the Net Manager is rsync, and then the backup data itself is then read-only. And we've now integrated, because we now have ZFS support in NetBSD, this is now all integrated with that, so it will automatically generate new ZFS snapshots as it goes along when it's done a backup. And then, because we're linked in with, we're still doing a lot of Citrix stuff, so remote access to give access to Windows virtual desktops. Then with the recent changes in SSL certificate lifespans, we need to automate this as much as possible. And so we've got tools that will automatically do that, so using Acme, but then know how to install those certificates, push those out onto Windows IIS servers or Citrix Nextscaler or Apache or Linux or anything that needs to use these. We have plugins, so it'll go and install these certificates on the relevant end device. So the configuration itself is mainly all runs from a single configuration file. All the configuration files themselves are all held in etc. Net Manager, but the main one itself is netman.conf, which is, it basically looks very much like a shell script. It is literally just variable name equals value. And then we have build scripts, which will go through and actually make these settings live. So you can hand edit this file, and then the build scripts will then make these settings live on the relevant services. As I say, the web admin itself is written in PHP, but we also have configuration wizards that you can run from the command line, which will also work on the same configuration file. So the build scripts work with roughly one per service, and they're named generally appropriately. So, you know, Apache is the one that will go through and configure all your virtual hosts, any reverse proxying you want to apply all your certificates. It'll set up authentication on virtual hosts if you want to do that sort of thing. Other examples would be, well, so our syncd, for instance, that will set up an syncd service as a listener. So if you have a net manager you're using as a file server, you may have a second one, which is your backup server. And so the communication between those is done using rsync, as I was saying. The configuration file itself, in general, is going to be enough to describe what the system is. So you can just copy the single file onto a fresh machine and just go, right, build this, and you'll have a working machine at the end of it. But if you've got things that are more complicated and can't really be described in one line, so for instance, DHCP leases or more complicated web filtering rules or firewall rules, then there may be some extra files in there just so you can customize it. Now, the build scripts themselves are designed to be pretty clever in terms of being forwards and backwards compatible. So as long as you've got the latest build scripts, you can run these on a very old Net Manager build, and it'll know what to do. It will detect the versions of the software you have on there and build up the configuration appropriately. And what that means also is that we can do things like completely switch the services. As we've changed our minds throughout the years of which firewall we want to use or which IMAP server we want to use, then the build scripts allow us to do that migration really seamlessly. The advantage of the build scripts is because we're declaring on the configuration file things like what your IP addresses are, so if you know where your IP addresses are and you know what your default gateway is, you can determine from that which of your interfaces like to be externally facing, which means you're going to apply different levels of firewalling on that. And so it will deal with all that automatically. So if you're doing things like Squid for your web filtering, it will only allow you to fetch web pages. If you're on an internal trusted network, you wouldn't be able to do that externally. And the same things for things like DNS recursion or dynamic DNS. So as a bit of an example here, here's a fragment of one of the settings files. So we're declaring some IP addresses. We can determine what our gateway IP address is and work out which network range we're on, which is going to be our external one, which is our internal one. And we basically say, we'd like some NAT on that, please. And we're going to use IP filter as our firewall. And so we run the build script. It will then configure ipnat.conf to do that mapping. It'll switch off NPF. It'll switch on IP filter. I can then go in, alter that configuration file, and change firewall to NPF. And it'll do the complete opposite. So it's now setting up NAT within NPF, switching on NPF, and disabling IP filter. And these the settings files are also then backed up every night as well, so you can also look at any differences. You've got a full audit trail of all the changes to that, and if it's been made through web admin, who did it, and when they did it, and what changes they made. So the build server script sort of controls all of this. So each individual build script says, I'm interested in this specific configuration variable and all these files. So for instance, if your gateway IP address changes, then that's going to have an impact on things like your firewalling in terms of NAT, but possibly things like, I don't know, CalDAV doesn't really matter. So they're going to go, I don't care about the gateway address. And so we have an overall build server script which compares before and after of the configuration files, sees which variables have changed, and now it knows which build scripts are actually relevant. On a complete update, then we use the -f option, which just runs every single one, because at that stage we might have very different bits of software behind the scenes. So to do one of these updates, we just a script called update server. It will go and check against our service to check that it's using the latest version of the update scripts, and if they're not, it will download the latest ones and restart itself. First thing it will do is update the individual sections of the net manager. So that's things like the kernels, the variant build scripts, and web admin. It will then also update all the package source packages. And as I was saying before, it syncs this with a list that you're entitled to with the features you have purchased. It will also go and check whether the ones you have installed match the OS version you have installed. So it means that to do an operating system upgrade, we can pretty much just change the kernel, reboot, run update server, and it will then swap out all the packages. Even if it's the same version of the package, you know, you were running the up-to-date one on your older operating system, it will spot that it will carry on working because of NetBSD's backwards compatibility, but we want to get things up to date. And then finally, it rebuilds all their settings with this -f flag to build server. Now, I was saying about the package list and it being modular, and that's because you can buy add-on modules. And we have a portal where all the customers' net managers are listed, and we can say which features they have, and we can also say when their support contracts expire and things like that. And so, for instance, we can see two net managers here. One of these is set as a file server. One of them is just an internet. And the one called new build, the second one of these, this is going to get things like VLC video streaming, whereas the first one of these won't get that. So the list of package source packages that they're given to install will be different, but also the list of build scripts they'll get will be different. And so as an example, the proxy content filtering, the thing that we're using to inspect HTTPS content, that's an add-on package. That isn't the sort of thing you're going to need on your backup servers and things like that, but you are going to probably want that on your firewall. And so that's a module you can get, and it will then be applied. So we track NetBSD. So I'm on the release engineering team in NetBSD, so I've got a bit of a vested interest here. But we're very conservative. Now, NetBSD, it doesn't have the fastest release cadence in the world. But even so, that's still too fast for me. And so historically, I've always used odd-numbered releases. And so, so we had 1.6, and then we had 2. And so I started off with 1.4, skipped 1.5, went on to 1.6. Next release after that was 2. So we've done 3, 5, 7, 9. Had to change all that last year because we do a lot of virtualization and tend to use Citrix Zen Server for that, or XCP-ng, and they dropped support for fully para-virtualized kernels. And so at that time, we then would have to switch to HVM. So this is where you have the generic kernel, but it has the para-virtualized NIC and storage drivers in there to get the best performance. And so we were forced to move to NetBSD 10 because that was the first release that had HVM mode. And so this was a bit of a line in the sand for us because Zen Server 8.4 came out, which basically killed all our installed base of machines. So it was a rather panicky sort of thing to go, okay, so we need to upgrade all those customers that are using it virtualized. We need to do it to NetBSD 10. But we're now on NetBSD 11 RC5. The release is going to be coming out real soon now. And so I think I'm going to try and get us back onto the odd-numbered releases. And then so we'll switch to 11, and then we can look for NetBSD 13, estimated completion date 2038. So in terms of the actual releases that we do to our customers, then package source does quarterly branches, and so we tend to track those. We support 2 different operating system releases, so the current one, and usually because of us doing the odd number of releases, N-2. Package source itself really supports the current release and the previous one, and that's the NetBSD support strategy for its release branches anyway. And so sometimes we need to do backporting of packages, to fix things. Certainly newer bits of software require newer versions of GCC that weren't in the base operating system at that time. But if we just go, well, this package just isn't going to build, and it's just not worth the effort, it's not a problem because of the build scripts being very dynamic. They'll just go, I can see you've got that old version. That's absolutely fine. I'll change the configuration for that. And so it isn't a problem at all. When we want to update the operating system, so we don't have things like package base and stuff like that we have in FreeBSD. So I've sort of invented our own similar sort of things. They're nowhere near as modular. So all the install sets that we use when you install the operating system, so you have things like base and comp and X server and text and man pages. All the files that are contained within that are all held in mtree files, which is also sort of part of the build mechanism, so that the way we do the unprivileged builds and all that sort of stuff, we just sort of get all this for free out of it because these are the spec files that say what's in each of these sets. So what this allows us to do is just go through and, in the basic thing, is just compare what's on disk. So all the checksums are in here, so we can compare what's on disk with what should be on the disk, so we can see if anything's been tampered with. But it also means we can compare that against the mtree files that are in the, say, the nightly builds, and see if anything needs updating. And so then we can just compare the two and do the updates, which also allows us to alter what's installed. So if you originally installed it and you put X on there, because you just said, yeah, you just install everything, but you go, well, hang on, this is a firewall, why do I want X? Then we can just uninstall that. We just go, I don't want X anymore. Or it might be that you want kernel debugging symbols, and so we can just add those. So it also allows us, and this is back in the history a little bit, but it allows us to switch platforms as well. So when we migrated from the i386 to AMD 64, so we switched from 32-bit to 64-bit, then the install scripts that we have would automatically deal with that as well by comparing the 2 sets of files and removing some things that were unnecessary. And so this is a product we still sell. This has now been going on for, well, it started in 96. I guess there's some sort of anniversary coming along. But of course, as we probably all know, it isn't necessarily easy selling these sort of things because people go, well, I do want my firewalls to be from a known brand, even if these known brands have many, many 0 days. Or I do want my file server to be Windows. And so people say, well, this is proprietary. My response is, well, no, not really. So the point is that people go, this isn't a thing I know about, therefore it must be proprietary. The answer is no, because it's not proprietary. This is open source. And if we cease to exist, then this can be supported by anyone who's familiar with this. Anybody who's ever managed Samba or anything like that can go and manage this system. And also, we're not going to push you away from having access to be able to manage this yourself. So we don't treat this as a closed box. We're happy for the customers to have full root access onto this, and it's really great when they come to us and go, well, that's nice. It'd be good if it had this feature. And so, we enjoy that. We enjoy empowering them. Or they might say, well, that thing we used to use it for, we don't need it now because we've got a different firewall. They go, well, yeah, but you could use it for something else. And so it might be that if you stick another couple of hard drives in it, it can now become a backup server. And so we've got a few customers who've done that. They bought it for one purpose. It's now used for something entirely different. Other challenges for us actually just working with this thing is that if we're trying to run this on real hardware, then we need to maintain compatibility with what's coming along down the line. We're a Lenovo business partner, so we tend to use Lenovo for that. And every time we get a new server comes along, it's always a little bit of a, heart in your mouth. I'm going to boot this thing. Is it going to even get to an install prompt? And if it does, is it going to find any NICs? Is it going to find any storage? And so if it doesn't find any NICs, okay, we can stick a network card in there for the moment. Send a D message to the mailing lists, and we've got some people who are pretty good at writing drivers on porting drivers for Intel network cards, if nothing else. And myself, I've ported various drivers from FreeBSD, so things like Adaptec, SCSI, and the Digium VoIP cards. And I think that's about it. So I've got a few references in here in that I did a presentation all about more history on running Unix and Linux on Acorn computers. And my original talk that I did 17 years ago, you can find them at this link here. So thank you very much. Does anybody have any questions?
Yeah, why did Apple buy that part of the company, or no comment?
Why did Apple buy the company when Exemplar were going under? Because they wanted to take everything back in-house. So this was the time when, so while I was working at Exemplar, that's when the first iMac came out. So it was all performers and stuff like that when I first started working there, but then the original Bondi Blue iMac came out, and crazy old stuff like the Apple eMate. So there was a mood of excitement in the Apple camp because this was pretty much just as Steve Jobs was coming back, and so I think they had been down in the doldrums for a while, and so does that answer the question?
Kind of. That's also when they had their disastrous tablet.
Yeah, so that was the Apple eMate, and there's a whole bunch of stuff in here with data loggers and all sorts of tedious things like that. But it was quite good. It was a good time to work there because it was sort of us against the bad Wintel people. Because our main competitor, Research Machines, they were Windows and Intel stuff down the line. And even when we started doing Windows file servers, who were using NT, we did it on the PowerPC variant, not the Intel stuff, just to be different.
If like something broke during an update or hardware issue, broken disk or something, or how did you remotely support it?
So we've got multiple ways of doing that. So for instance, we have a system where when we do an operating system updates, then we pretty much just ship out a USB stick, boots from USB, and then it then grovels into the file systems, finds the settings that it needs, configures the external IP addresses, sets up SSH with the relevant keys and things like that so we can connect in. That's generally the way we do it. If we do major updates, we tend to just try and sell them on-site services, to be honest, because there'll be something else we can do at the time, like introduce some feature that they're not using. Any other questions? Okay, thank you very much.
half an hour to do them, so we'll see how the math works out. This is Devin, and if everybody who is talking can make their way down here before the previous person finishes, then we can hand the mic off and avoid losing extra time that way. You can get started.
Hello, my name is Devin, and this will be an exercise in brevity. If you've seen any of my previous talks, you'll know that they were long, and this is not long. Without much further ado, I had some new artwork developed, and I wanted to share it with you today. And let's just preface it with Beastie is 38 years old now, and is technically old enough to have an 18-year-old child. And so this is not a new derivative of Beastie that I'd like to introduce today. There will be some iconic elements that you recognize, and it's altogether new, but we have the shoes, the trident, which is actually a pitchfork, reminiscent of the system called fork. But somebody here said that the original had red shoes, so we made a red-shoed version, and I'm just proud to share it with you. Not sure how we're going to use it quite yet, but thought it was worth sharing. That's it.
Okay, Warner is next.
And we have a question like,
We're not doing questions. There's no time for questions.
does that work?
Press the button there.
Okay, so I'm going to talk a little bit about the boot issue that we had that caused 15.1 RC3. The problem is we had a hang-on boot, or we'd get a register dump like this when we would boot. And we didn't really know a whole lot. We thought it was microcode related. In fact, Caustic fixed a number of microcode bugs, but it still persisted. And we knew that if we created a big enough staging area, it didn't happen, which was a little bit odd. So I always thought, hey, this has got to be a buffer overflow or something of some kind. That's kind of what I approached this with. At the last minute before we did the release, Colin said, hey, can you take a look at this? I'd been meaning to and decided I'd start looking into it. So, and the other thing that was weird was when Netflix did their update, we hit this without having microcode. So that also made me very interested in what's going on. So I thought, okay, Colin asked me to do this. I've burned my whole day with work stuff, but I got a few minutes before dinner. Let me toss this into Claude and see what it says about the backtrace. So I put what I knew into Claude and told it a few things. And it said, oh, you're not really executing the code you think you are, because these registers should be different values than they are. If I had longer to talk, I'd explain all the details, but it's like, oh, that's interesting. I just wanted to know what the privileged processor state was and get a little bit better information, and it decided to go off and do all these things. So Claude had a bunch of debugging suggestions. I put all these up before I realized this talk was running short on time, but none of these were practical. I'll just talk about the first one, which is the obvious one. Oh, check to make sure you're jumping to the push instruction. Well, we load the page table and then return to the first instruction, so there's no opportunity to do that. And even if we futzed with that, we couldn't print because we'd already exited boot services, and we don't have a console between when we exit boot services and FreeBSD establishes a console just before it prints the copyright message. So none of these suggestions were good. So I thought, okay, I'll talk to Claude a little bit more and say, hey, how could the bootloader step on this table? And it gave me a bunch of wrong answers that were obvious BS, so I thought, let me give a little more context. So I said, look, I know that we have disabled staging, and we pass BI true to, we pass true to BI load, which causes exit boot services, so I can't really do any of the things you told me to do. What's next? It's kind of what I was thinking, and this is kind of the chatty thing I wrote. And the answer was, well, now that I'm looking at BI load, it calls if I copy in, which calls a number of things, which could move the staging area, why don't you add some printfs? So it's like, okay, I can add some printfs. The line it suggested was wrong, but I found a good line to add it to. And so we start out at 568,000, and we wind up at 568,000. So I told Claude this, and it said, oh, you know, UEFI tracks the allocation, so you're not overflowing it, but that value of staging is encoded into the page table that you're loading. So if you move it, your page table's screwed, and of course you're going to jump to who knows where. So, you know, move this around. And the result is I moved it around. Now, I moved like 40 lines of code, so I can't put that diff up here because diff thinks I moved other lines of code elsewhere. But basically, you know, with about, you know, an hour's worth of my time and, you know, a large elapsed time because I took a break for dinner. I said dinner was almost ready, so about halfway through I took a break. But this problem that would have taken me probably a week of really hard stare at it, look at it, you know, look at this theory, look at that theory, I was able to solve in an evening, and we were able to do the next release more quickly. And the one thing I want to highlight here is the cost was like $3 to do this. So that's all I have. I guess we'll go to the next talk. If that's Dan, I'll hand him the pointer too.
I'm quite sure this will be a quick talk, so the next person should start moving now. Last week, I was in Charlotte, North Carolina to attend Southeast Linux Fest to give a talk about ZFS. While I was there, I listened to a talk about Victoria logs, and I got really interested in it because I've never done any log consolidation apart from Elasticsearch way back when, but that died a horrible death because I was running it in jails and it didn't like that. So I abandoned that. But basically what it does, puts all your logs, you can search metrics. Mostly for me, I want to answer this question when I wake up in the morning. Why did the web server get absolutely hammered at that time? And at the moment, that's grep and sort and crap like that I don't want to be doing when I'm figuring this out. Arrow? Too far. So what I did is I spun up logs.int.unix@home.org and installed this package on it. Installing the package was straightforward because it's a FreeBSD port, but I started importing all the Nginx logs, and it works rather well. So there's about 2 hours. No, what's this say? Anyway, that's what that UI looks like. You can drill down into a given one and look at what's going on. I hid the host name for this because I don't want you hitting it. But it's fairly easy to configure and set up. That's all the stuff that came in over a certain time period. I'm sort of interested in spikes like that, and that. This is a longer interval. You can change how wide the graph bars are. That tells you how long the query took. That's your sample size that it pulled out. So this isn't a very big, very busy server. To get the Nginx logs in, you just create a format like this, which is just JSON. And you tell it to do that. It's easy to do that. And then you tell it to put the logs into a file in that format. I kept my existing logs because I still like to read them from time to time. JSON logs are horrible for humans to read. And then I use systemlog.ng to transport the logs into Victoria logs. I said, that's the file you're going to be reading from. That's where you're going to be sending them to. It's straight JSON in and straight JSON out. And basically, you read from there, you write to there, and boom, it's in Victoria logs. So why do I use syslog.ng? Because it has TLS and syslog doesn't. Plus, I'm sending JSON, so it's easier to do that in syslog.ng. There are other tools. FileBeats would do this as well. There's a whole lot of tools you can use to get stuff into Victoria logs. How much time? Oh, good, because I'm done. I've got a bunch of blog posts up there, probably 5 or 6, with sample configurations that should get you going. And if they don't get you going, please tell me, because there's something wrong with them. I've been refining and breaking and fixing over the past few days, and I've become overly obsessed with it, and I think it's going to be a really great tool to add to the toolbox. Thank you.
Okay, Seth is next.
Good afternoon. Is this working? Yeah, wonderful, this end. Good afternoon, everyone. My name's Seth Drake. I'm a complete interloper here because I'm really not BSD, I'm hardware. Some of you may have seen my blinking lights at the end of the corridor. Some of you have even been kind enough to stop and say hello. I appreciate that very much. I'm going to talk very briefly about my Sparrowhawk CPU. So, what I was trying to get was to bring back the spirit of the 70s and the 80s, because I'm a Commodore brat and I have nothing better to do during COVID. So what I was trying to do was to build a CPU that was simple enough for one person to understand, i.e. me, because I designed it and I'm not very smart. I wanted to be able to point it at education because I thought it might be useful. And I wanted it to be able to be usable by hobbyists. So I remember the days when you could walk down the street and buy a chip whenever you happened to want one. And I thought this was a good idea, and it was better than sitting and watching YouTube all day. So I came up with Sparrowhawk, and the reason I called it Sparrowhawk is because a sparrowhawk in the wild is a small bird of prey that is small, surprisingly capable for its size, and notoriously difficult to train properly. And Sparrowhawk is one of those things that if you like a challenge to code for, to get the best out of something, you are going to either hate Sparrowhawk or love it at the same time. So why create it? Really, I've already said this. It started out as a COVID project to keep a promise to myself to develop a CBM basic interpreter. I used to teach compilers, I used to teach computer science, and this was just something I wanted to do. Out of that, when I got that, I thought, okay, this is great as a REPL, can it run a program? Then it ran a program, and I thought this would be great if it looked like a VIC-20, so I made it look like a VIC-20. And from then, I developed my own basic, and then I thought, oh, I need a chip. What chip am I going to simulate? And that's when I ran into the question, what do you build? And I shelved the project for a little bit. And thought about it, and I said I wanted something that was kind of like a 6502, but kind of RISC as well. My 4 favorite computers across the bottom, some of you may recognize some or all of them. Basically, Sparrowhawk is, as you see it on the screen, has a 16-bit data bus, 20-bit internally, and 16 32-bit registers, of which three are core registers: PC, program counter, stack pointer, and link register. I designed it very much to be interoperable. I wanted it to be usable by as wide a range of people as possible. So it comes with coprocessor pins and DMA pinout. It also actually has a Phi2 designed into it as a bit of a nod to Commodore if anybody ever wants to use a Phi2. The ISA is optimized for 16 bits to try and get as much code density as possible. And as a result of that, you can do full word, you can do half word and byte operations, and you can load things into a register without disrupting the other sublanes. You can store bytes, you can store half words. It's tried to be as tight as possible code-wise, but above all, I wanted it to be predictable. I designed it, it doesn't have all of the modern RISC tricks. It just doesn't have them. That really was because I couldn't design them, but it's turned Sparrowhawk into an unusual core for modern days because it just doesn't have any of the tricks. Where are we now?
Well, some of you will have seen, and it's over there, we have blinkies. We love the blinkies. We're in debugging. We've just attracted our first little bit of investment, so we can start moving forwards towards commercialization. And we have a developing tool chain, the IBIS C compiler Ornithos, which lets me drive the interface and the Firebird computer, which is what looks pretty when you drive the script, when you look at it. Design for understanding is really what Sparrowhawk is all about. Thank you for your time. Thank you for making an interloper welcome. Have a great weekend. Thank you.
Check one, check two.
You have to hold them like this. If you eat these ones, they're connected. You're clipping the.
Yeah, but we're not getting anything right at the moment. Check, check one, check. Cool. Who's next?
I think it's me.
There you go.
Hope it's me anyway. Well, let's see. Oh, hey, look, that is me. So, down here? Yeah, we good? All right, cool. I just want to bring up the idea that a Raspberry Pi is an extremely powerful computer today. Like, everyone thinks of these as just like little toys. And if you're here for the FreeBSD Developer Summit, I had a whole talk on how I built a tool chain for building images. And this is the first appliance that I built with it. In that talk, I broke a lot of different things. You can see a screenshot here from the talk from this very room just a couple days ago. A lot of the bugs, I broke ZFS a lot. I also, if you think just flashing the SD card should be simple, I broke that a lot too, because apparently the Raspberry Pi imager doesn't know what Z standard is, even though they claim they do. Anyway, last night when I was talking with Alan Jude, I mentioned like this weird little issue that I had. It's not really an issue, just it's mostly cosmetic, but apparently I discovered yet another ZFS bug just last night. So when we do zpool history, because I'm using temp names when creating the pool, it's logging the wrong name to the zpool history. I thought I would have to go file another bug report for this, but then today I was looking this up and it looked like somebody has actually just filed this bug. They caught it right before I did, so this might already be fixed. So I'll have to go and validate that, but this has all been within the past 24 hours, so I don't know yet. But what I wanted to show is like what I didn't get to really mention in my talk the other day was the actual like more details of what this is really doing. So I'm using, there's a few different models of Raspberry Pi 4, which isn't really conveyed too much. There's two different CPU clock speeds you can get. There's a 1500, there's an 1800. I'm using the 1800 with 8 gigs of RAM. Even though it turns out I don't need it, I'm only using about 2 gigs of RAM for everything on it right now. The Pi is an NTP server with a GPS-based source. And I went and pulled the most recent stats from it, so these numbers are actually a little bit higher than my last talk. It is currently serving 213 requests per second, and that's 18 million clients a day that this thing is serving from a single Raspberry Pi. And it's all doing that at, I believe it was under 6% CPU usage. So like a Raspberry Pi, some people think of it as a toy. This is doing real world production loads. That load is part of the public NTP pool. So if you use like the normal NTP pool, that should be configured with NTPD or any other the NTP softwares. I am probably serving your NTP requests now, if you're here in North America. Next, right. Oh, whoops. Anyway, this has been my development Raspberry Pi since January 1st. That's when the main development of this project started. I went and put my name on it, and then I somehow lost it somewhere. So if somebody wants to bid on it later, you might be able to get a little bit of piece of my history of what I've been developing this whole time. So that was the real reason I wanted to give a lightning talk, to let you guys know that like if you want to take a little piece of my history, you're welcome. Anyway, if you want to check out the project, the QR code there goes to stratapi.com, which redirects you directly to the GitHub page, and I have some contact information there if you want to get a hold of me.
Yeah. Can you guys hear me? Okay. Yeah. I'm Surojit. I'm I studied physics and math and physics at Waterloo. I sometimes fail to write fluid sims. Usually they blow up. Sometimes they don't. I do a bit of GPU programming because I need to make those fluid sims run fast. This term I'm interning at the FreeBSD Foundation to try to get ROCm, which is AMD's compute platform working on FreeBSD natively. What is ROCm and why care? ROCm is AMD's version of CUDA. It lets you run code on the GPU. But why care? If you guys want to run AI, LLMs, machine learning, or random things like fluid simulations on FreeBSD right now, you either have to run them on the CPU or pass the GPU to a Linux or a Windows virtual machine and kind of emulate it. That has a really big performance hit. And yeah, so if we can get ROCm running on FreeBSD natively, we can start to avoid that performance hit. You probably need a lot more work to make it run like as well, but you know, it's a start. What have I done so far? I have made some changes to AMD's LLVM fork. That one change has been upstreamed. ROCm core compiles with no changes. That's a very nice thing. The ROCm runtime, which does most of the thinking, has many changes that need to be upstreamed, and they've still not replied yet. I really should go bug them soon. I did write a NUMA CTL shim layer. I did get a suggestion from someone that I should look into the one that's, there probably exists one in ports that I did not think about before. I have to go look at that one later. I did try to port DRM KMod, the specific version I needed, like this, or the specific parts I needed, before realizing that is a bad idea. I did upstream some changes though that were needed a bit later. What are some things I'm skipping? If you guys do GPU programming, you'll have heard the word shared virtual memory. I am entirely skipping that because I am not writing heterogeneous memory system for FreeBSD. I'm not doing that in 2 months. I'm skipping ray tracing, scary computational libraries, and anything that I do not need to get simple vector addition working. What needs to be done? AMD KFD is I'm still working on porting that. It is going to take a bit more time. Someone needs to take a good hard look at heterogeneous memory management because a lot of modern GPU programming now does use that, and whether it's worth the time and effort to add it in. I know Linux does have support for it, Windows does, and Mac OS does, so it may be worth it for someone at FreeBSD who has a lot more knowledge on memory systems to look at it. And I need to look at replacing how the NUMA CTL shim I'm using. Thank you, Oliver, for the advice yesterday. And I need to look at how NUMA handles GPU memory, because I've learned that is different than what I thought. If you guys are interested in this work, here's some blog posts. Reach out if you're interested. I have learned some of the things in these blog posts are wrong. So yeah.
2 minutes to spare.
Hello again. This will be slightly longer. So I'm working on the Framework laptops, and I bought a laptop with the Framework 12 that you see on the floor table over there. And it did not do S3 out of the box, and you could not wake it up. The display went black. And then I tried, let's use S2 until the meantime, but that didn't work either. So here I'd like to talk about all the people that have Framework laptops, but this potentially applies to more than Framework. So what I have working today on the Framework 12 is we have suspend resume with S0IX and S2, and in the past hour I got S3 working. With S2, I'm changing the power button and the lid switch. In the past hour I'm now using the button state for S3, but here we had a problem, is that every time you put the thing to sleep, you lost your touch screen, you lost 3-finger gestures on the trackpad, you lost middle clicking abilities, and that was not acceptable. After 22 hours of debugging and multiple days of head scratching, I realized it was in the kernel and not in the window manager or any of the device things that we can do. I banged my head on this thing for quite a while. And so the patch that I raised, which Adrian has reviewed and made me improve a little bit, actually improving code that was already there, we found out that this is actually Intel specific and works any laptop using Skylake or higher is probably affected. So in the low power subsystem, that's where the problem lies, literally lies, where the hardware is supposed to advertise what requirements are needed when we're coming out of a S2 sleep state on how to kick the hardware back into running. And so a 4-line patch was all that was needed in order to get the hardware to reinitialize after coming out of S2. And so I've been working on this laptop for a little bit now. I've developed some custom solutions to the media keys that are on these laptops that are not window manager specific. They could potentially be applied to other window managers. I did use Cursor for this. I had it whip up some C code that uses XFT and directly blitz into the frame buffer because I went in the background and started compiling LLVM and then just told Cursor, keep making it faster and more seamless until I can literally just spam the volume up and down keys and have it completely fluid even while saturating all cores. So that was great. So we have brightness, we have print screen and volume all working. And then on external displays for a situation like this, I wanted to be able to plug in a DisplayPort, HDMI, or USB-C and hit a screen mirroring button because we have F9 on here with the little icon for screen mirroring. I wanted to be able to use it. So I implemented that. And then Deb said, well, I don't want screen mirroring. I want screen extension. So I added those to my window manager. I haven't yet had a chance to test those yet, but I presume that they work. It's just Xrand R. And then so my window manager of choice is the one that nobody else uses, which was FVWM3. Oh, we got one other user in here, but I've been using FVWM for 20 years. It started with FVWM95, then FVWM2, and now FVWM3, and I'm still using Xorg, but I've just recently been told that the same person that does FVWM3 is doing the Cow project, which is something over Wayland. I don't yet use Wayland, but when I do get to Wayland, I'll probably be using Cow as my desktop, my window manager. Let's see here. And then so some of the limitations that I found that are bugs in the firmware is that if you're in S2 and you happen to unplug the AC cable, it will wake up. That is not really cool, especially if you've closed the lid first and it's gone into S2 and then you unplug, your laptop is not actually sleeping in an idle state when you put it in your backpack. It is awake, display running. And so I tried to fix that and I failed. I'm just admitting it's a limitation. I might have to upgrade the firmware or bug framework about it. What is next? Like a Mac, I'm very quickly throwing my Mac. It's actually my Mac is borrowed from my spouse, but I don't even want to use the Mac anymore because the framework is so slick. But if I have some wishes I could grant, I would be doing pinch to zoom on the touchscreen because it's a wonderful tablet as well, and a couple of other gestures that might be on the screen. I have those working on the trackpad, but not on the touchscreen. So how we got here is a timeline. I started a little bit before the conference on the Saturday before I flew out on Monday, and things didn't work. So I spent multiple days diagnosing issues and fixing them rapid fire, and the breakthrough was on June 18th when we found the root cause after adding many debug statements to the kernel, rebooting to them, crashing several times, having to roll back, and then feeding all of the registers, because I don't have the patience for reading hex symbols out of register dumps. I fed those into the AI, and it was telling me what was going on, and I approved everything, and now we have patches. And that's it.
Announcement. It's a very important announcement, especially for BSDCan. We have cookies. They are available in the lunch section. Enjoy.
more complete error message information. And that's exactly what extended errors are going to allow you to do. So why do we have this business of just error numbers? And to understand that, you have to look back to the time when Unix was being written. And it was developed on 16-bit PDP-11s. So you only got 65K of text. And then on the fancier PDP-11s, you actually had what was called split IND. So you had 64K of text and 64K of data. Now, 64K of text is about 10,000 lines of C code. So your kernel cannot be bigger than 10,000 lines of code. And so it's pretty impressive, to think that they got an entire Unix kernel that would actually fit in something that small. I mean, at one point I was railing about the fact that one of our device drivers for a disk was 35,000 lines of code. That's 3.5 times what would fit on a PDP-11, and you need more than just a disk driver. Okay, so strings are using up that very precious text space, because that's part of your address space. And so rather than having the kernel return error strings, it's much more compact to just have a list of numbers. So you want to return enval, that's just load that number into R0 and return. And so it was a very compact way of being able to get error numbers back. And then when you get the error number back, of course, then in user space, we can expand it into a string. So you return the number 27 or whatever it is, and then in user space we say, we index into an array of strings and say that's invalid address or whatever. Okay, so it made a great deal of sense with the PDP-11. Well, I don't know if you've noticed, but with 64-bit address spaces, we don't have to worry so much about strings. And so it is now possible to, in fact, have strings formatted or return string type of responses from the kernel. Now, how much are we really talking about here? Well, in the case of embedded systems, which often have limited resources, CPU speed, memory, and they may be only 32-bit processors, and if it's an embedded thing, you don't need extended error messages. You're not talking to a user. You're just running some application. And so, in fact, it is possible to say, I want to build my kernel without the extended error strings. When Caustic first did it, the option you needed to get the extended errors was bloat kernel with ext error. But we decided that wasn't really, it was descriptive, but it just got changed to x error under strings. So if you compile if you don't compile with that, with ext error under strings, then all those error strings get stripped out, and so you don't have that extra space to have to deal with. Now, what's the effect of actually doing that? Well, at the moment, there's not very many of them, so it saves you a whoop 2K bytes. But if we actually expand it to all 54,000 errors that are returned from the kernel, those strings are going to blow up. So, for example, kassert, which we've had for quite a while now, if you compile without it, you save 676 kilobytes of string space. And my expectation is that this will grow to something on the order of that. So it is a non-trivial thing. And so when I go through how it actually works, there's a bit of machinations that seem to make it more complex than it needs to be. But the reason is so that it's possible to build kernels without the external error strings in the kernel. Okay? Okay, I sort of said why we need it, but some error codes are heavily used, and the errors return. It can be difficult to understand it. Enval alone comes back from 14,000 places in the kernel. Recently, somebody put up a thing for review and the subject line was, provide external errors for eInval. I said, perhaps you need to specify which file you're talking about, unless you actually are planning to put in 14,000 new things in the kernel. And I believe they did that. Anyway, as I've already said, it's returned for 16 different reasons just in the mmap system call alone. Currently, there's only about 200 extended error messages in the kernel. Actually, I did these slides about 3 weeks ago, and I just recently checked, and it's more like 400 now. So people are really starting to use them a lot more. And many more are needed. So for any of you that do stuff in the kernel, if you come across a few error returns, feel free to put them in. I'll give you the clue on how you do that shortly. Okay, so how do you actually go about putting them in? Each kernel, it goes on a file-by-file basis. And so if you want to add external errors to a file that doesn't already have some in it, you need to essentially indicate that this file is going to have external errors. And so it has to register itself, this file has to be registered in /exterror under cat.h. And then you have to enter your category there. And really what this is just a list of numbers. The reason that it's all this complicated is because the strings are put in a certain place, and then it returns which file it's in so that we can tell you this error occurred at this line in this file, which if you're trying to debug the kernel, it's actually quite a useful thing to know. All right, so I was working on mmap. It just happened to be the first one that we were doing. And so you say scratch define xerror under cat, and then the last thing here is just the name of the file typically. So I was in VM under mmap, so I just called it mmap. And when you look at this file, it's just a whole long list of numbers. You just take the next number that's in the file. There's about 25 of them now, so you put one in, it'll probably be 26 or whatever. Okay, so you put that into this file. And then in the file that you actually want to add the extended errors to, you have to include sys exterror.var.h. And before that, you have to say what the name is for this file. So the xdir category, in my case, is xdir under mmap, which is what I defined up here. And if you don't have this in the line before this one, then you're going to get an error, a compile time error. All right, so this order is important. You have to define it and then include it. And of course, you have to have created it in the first place. All right, so as I say, it's a little complicated, but the reason is, again, so that we're going to be able to strip those things out easily. And also so that we can, when an error occurs, we can tell you what line in what file it happened. All right. So having done all that, how do we actually go about putting in an external error? So I just picked a random example here from mmap, which is one of the ones that I was working on. And so what it used to say is if the protection that the user has provided is something that's not in the list of all the valid protections, then return eInval. All right. So what that becomes is the exact same if statement, but instead of returning eInval, now you return exterror, and then what the old value was, eInval. And then you get to provide a string, and you can have up to 2 parameters in it. So unknown protection bits, in this case, I'll just print out the hexadecimal value of what the user supplied. So you'll, 0x blah, blah, blah. And you can then look up and say, oh, I wonder where I got that from. And as I say, you can have up to 2 values in there. And what the user will see is this string with those 2 values printed out. or 1 in this case. Okay, so it's not an arbitrary. You can't have like 3 or 4 or 5 values, but you can have 1 or 2. Okay, so that's going to then end up giving the user a much better understanding of why this thing failed. All right, so now that's all well and good, but how does the user actually get to see these things? And you're going to say, great, now I have to go through every single utility and ports and base and print these things out. So obviously that's a non-starter. And so in order to bootstrap this process, we essentially put it into some of the existing infrastructure. So how does that actually work? Well, first of all, each thread in a process has to say that they want to get these things. And again, you don't want to have to go through and change every program to register the fact that they want extended error messages. So by default, the C runtime sets up such a structure that it needs. Essentially, what you have to do is allocate some space, a chunk of memory, and then say to the kernel, that's where I want you to put the extended error message. So the C library sets up the buffer for the initial thread, and the threading library sets up a buffer for each thread independently as part of the creation. Unfortunately, what that means is that language runtimes that don't use the C runtime, such as Go, don't currently provide you with extended errors. It would not be difficult to go in and make that as part of starting up, but as far as I know, that hasn't yet happened. All right, so for now, you've got to be running something that's a C program, but trivial to get other things. All right. So if a system call generates an extended error message, then its details get copied into that registered structure. What this means is there's no overhead for successful system calls. If you don't have an error, no extra work gets done. So we're not paying some extra overhead cost for having these things available. Also, there's no overhead. If you have threads that don't want to deal with extended error messages, you can simply delete their extended error structure. So I'm thinking here an embedded application, something like that. If they haven't compiled the kernel not to do them, they can do it on a per process basis by simply deleting that extended error structure. The extended error messages are constructed from the user-supplied structure, and then, in order that you'll get them, they are printed out by the error3 routine. So this is err and warn and all of those various and sundry things. So if the application is already using those interfaces, then this extended error messages will simply come out there. You'll still see whatever they printed out before, and then it just adds on. It'll say e-inval, invalid argument, and then the extended error message following that. Now, many routines don't use the error functions. And you say, oh, well, now I'm stuck. I'm not going to put that in and recompile the program, et cetera. So it's also possible to get them with kdump. So if you just ktrace your program, and then when you run kdump, you look at that system call, and the kdump will include the extended error message as part of the return value. So hopefully this will solve your problem. If it doesn't, you can use ktrace and kdump to find out what those errors were. And the error that you'll actually get is whatever that formatted extended error is, and then it'll also tell you what file and what line and what file the actual error occurred. So if you're actually trying to debug something in the kernel, it'll say kern or sys/vm/vm under mmap line 27, and so you can just go and look at it. Okay, so far so good. Yeah.
Is there a mechanism to explicitly get the extended error message if you're not using the error routines?
Yes, there is actually a routine you can call in the C library, and it just returns a pointer to the formatted string. I don't know if it has the kernel information in it. It may be just the formatted string. Yeah, and I mean, that can occasionally be useful because it gets overwritten with every system call that you do. And so if you want to save one and then do like another system call to print it out, say, then it's useful to do that. If you want sort of the gory details, Ext error section 9 is the manual page to look at. That documents all of those various special routines. Yes?
Is Pierre included in being aware of the extended errors?
Is which?
Pierre, the C library function?
I don't know. Yeah, I don't. I would have to look. If it doesn't, it should. Okay. So, what does this look like? So here I've gone through and just shown a few examples. So the text in the top part of this slide is a piece of a file that I just called examples. And so we take the file name that's of interest, we open it, we stat it, we see what its length is. So then I've said here, the protection I want is prot read or prot write, and the mapping is map file, map no sync, and then I call mmap with all of these various and sundry things. And then it says, I run it, and it has an invalid argument, big surprise, unknown prot bits 0x800. And that's because I used the wrong names here for the prot. So I got different protection for something that wasn't associated with mmap, and hence this came out. Okay, and by default, it just shows just this, the error just shows this error message. If I want to actually find out where it is in the kernel itself, then I can do this setenv here with xdir under verbose, and if I set that, then I get not only the error itself here, but also the source, which is sysvm vm under mmap line 200. So for the normal users, all they see is just the error message itself. But if you set this environment variable, then you'll also get where it is in the kernel. If you're running kdump, you just get this all the time, whether you like it or not. All right? So again, I'll just give you, a few more examples here. I use mmap because of the fact that it so overloads einval. So in this particular case here, we do the mmap, and then when we run it, again, we get invalid argument. But what I've done is I've said that I want an anonymous mapping, but then I gave a file descriptor to do the mapping from. And so it says, your file descriptor 3 is not -1, which is what's required for map under anon. So again, it's much easier to understand what you did wrong when you get that than invalid argument. Okay, another one we have down here where we've tried to run it, and I've asked for, I want to create a stack, but then I gave it a protection of read-only. And a stack that's read-only is not going to be a particularly useful stack. And so again, oh, that's invalid. Well, why is it invalid? Well, it's invalid because you're asking for a stack, but you've only given read access to it. All right? And then yet another example of an einval down here. We have an invalid argument. We've asked for both private and shared mapping. And it's one or the other. You're either private or you're shared, but you're not both at the same time. And so again, both flags are set, and you don't really need to see the flags, but it was easy enough to pass that argument back. So, the takeaway of all this is not to be a tutorial on how not to use mmap, but just an example of, you are using mmap, and suddenly when you get an error, you have some clue of being able to figure out why you got that error. And again, if this error message isn't close enough, then just get it to tell you, what line in what file, and you can go look at the logic yourself and figure it out. Or if it's broken, fix it. All right. Now, I'm incapable of giving any lecture without, trying to teach you a little bit about how the FreeBSD kernel is set up. What I ultimately want to tell you about is how do we deal with getting external errors back from device drivers and other things like that, because they're not typically running concurrently with your program. And the place to put errors is in part of your program, your process context. So in order to understand what's going on, you sort of have to understand how things like I/O work in the system. So back in the days when dinosaurs ruled the earth and I was teaching at the university, I used to teach a class, the OS class. And unsurprisingly, the example OS that we used at the time was BSD. And so one of the things I did is I asked the students to come up with a single piece of paper that had the entire kernel on it. And one of my students, they struggled with this. But one student actually had access to a giant print plotter at work. And so he showed up with it was probably about 2 meters wide, and he just kicked this tube that ran all the way down the hallway. And it was every function with lines between, who called what. I said, all right, you're on one piece of paper, but wasn't quite what I had in mind. So anyway, this is sort of a distillation getting down to something that pretty much does that. So at the bottom here, we have the hardware, and at the top, we have the system call layer. I was giving a tutorial to some folks at Intel that did hardware. And one of them comes up to me and says, yeah, that's all the friction that makes our processors look bad. It's like, I'd like to think we provide some value. But OK, anyway, so when you're doing system calls, that you're typically working with file descriptors. So they either come in and deal with vnodes, which get you down into either TTYs, line disciplines, ultimately to character device drivers. You get to raw disks. Or you're coming down into the VM system where you have various and sundry things mapped, which sits on top of the page cache. But ultimately, we need to do I/O down to get stuff from disks. And so what ends up happening is that a request gets put together. It then passes down through the geom layer, the CAM layer, and ultimately will get sent over the new bus to some bit of hardware. Now, although it's possible to have that synchronously happen all the way down, typically what happens is it gets handed off at some point. And for example, a disk will be done with something, and then it will just look on a queue. And so the context that it's running in is a kernel-only thread that's being used to run that particular device. It's interrupt handler. And so if it generates an error, it can generate an extended error message, but it goes to that thread that's in the kernel, and there's no way that it can be handed back to the original process that initiated that I/O request effectively. So what Caustic ended up doing was for each kernel thread, he attaches one of those little places to put the extended error. And so then what happens is normally you come down here, and then when the I/O completes, it works its way back up. And so that at the geom layer, that kernel thread will essentially issue a wake up to whoever was waiting for that particular I/O to complete. And what it will do is it will copy that extended error message from its buffer into the buffer of the thing it's about to wake up. And so now when that thing wakes up, it has the extended error message that was originally generated way down here in one of the device drivers. Okay, so in this way, we have a mechanism for all of this low-level stuff in the system to end up being passed back to the threads to which they're relevant so that they can see something about some error on a drive. Okay. So that's your theory for today. You can now wake up again. Yeah, this essentially goes through in detail to say what I just said. So you allocate a buffer from which the request will be done, an empty buffer for reading, or filled buffer for writing. You create this biostructure to describe the I/O, and it contains a pointer to the data and the buffer and so on. It also contains the pointer to the geom entry on which the I/O is going to be done, and then it waits for the I/O to happen. The request can be handled by direct dispatch. That is, the thread can just continue its way down. There's also a G down thread that can take it. But at some point, it goes off, and the disk is going to run. And the disk interrupt is going to be the context in which any errors are going to be generated. It's going to work its way back up to the top. And so as I say, when it gets to the point where it finds who needs to know about this, then that error will get copied over to them so that they will be able to see it. Okay, so the extended errors require a user process to report them. Only the threads doing the system calls have that context, so they can't return it. And that's why we end up with this mechanism with the extra error structure in that buffer or biostructure. And then we copy that error from that buffer back out to the user. And so EIO, which is even more common than EINVAL, you can now find out in much more detail, I got EIO. Well, maybe it's because the disk died, or maybe it's because that particular sector was bad, or whatever it is, you'll get that error back, not just EIO, that the IO didn't work. Now, that being said, most of the EIOs have not yet been turned into extended errors. But the hope is that as time goes on, this will get done. So sort of the history here. The framework is fully in place. It got put in place by about March of this year. And initially, there was Caustic and myself were pretty much the only people that were using it. And so I started sort of beating the can and trying to get some other people to do it. And you can see already that a number of people have, in fact, started putting things in. And I did this slide like 3 weeks ago or so, and already this list has doubled. Now, it did help that I gave a plea for people at in the Dev Summit to start putting in extended errors. And I noticed a flurry of them followed my talk. So obviously, the message did get across. But if you're working on any subsystem in the kernel, by all means, please do go ahead and start putting in these extended errors, especially for things that are common errors that come back. I mean, there's a whole lot of EINVAL for some ridiculously obscure reason that's just likely going to happen on the third week of the month with a full moon or something. But if it's a common error, especially one that a user could respond to in some way, is super helpful to have these things put in. And I mean, it's particularly useful if you're like actually trying to write the code and you're doing mmap and it's failing. But even if it's just an end user, knowing that the reason that their I/O failed is because the disk is having problems, as opposed to some other reason is a very helpful thing to have. Okay. So that is my presentation. My email, my website, my YouTube channel. Thanks to Netflix that has supported me on this particular project. And I will take questions. Yeah. Is there a microphone that can go around?
Yes, there is a microphone down there.
Yeah. Whoop. Using the microphone is the benefit to the people out on the web, because then they can hear what your question is too.
Yes, and the recording.
Guess the question.
So 2 questions.
Yeah.
So is there like some facility for like say the C library or whatever to be able to return these structures to applications? And the second one is, why were strings considered instead of something like an NTH result or something, which would just be like a regular integer that would encode like much more than like what a typical Unix arrow currently has?
Yeah. All right. So two points. There is a function you can call, and it will just give you back the error string. If you want to, just get it for yourself to do something else with it. The business with extended numbers is this lets us not only return strings, but also additional information in that string. So not only that the protection is wrong, but what you specified that's not correct.
Yeah, so some of this was inspired by a completely different implementation we did in Cherry BSD. And it's really essential that you be able to return values so that you can see what you did wrong. And in particular, when the value has been manipulated on the way through, it's just like in mmap in particular, especially once we have capabilities which aren't just integers, you need to be able to like see what happened.
Yeah,
and also the other reason we're not doing like a catalog thing is I'm completely convinced that if we did a catalog, there would be, the error messages kib added, and there would be no other messages because it's such a pain in the ass. This has the downside that it makes translation harder and things like that, but frankly, developer friction is the most important thing here.
Yeah, I mean, just to add to what you just said, the strings are, they're spread out all through the kernel, and so it does make change different, but the problem is you invariably end up with a mismatch between the index into those strings and what got returned. And so you end up often getting the wrong string printed out to you. But really the more important point is that you can return more specific information. Particularly, as he was saying with mmap, a lot of times there's manipulation of your argument. So they took your argument, but they anded and ored and did other things with it. And so the thing that's failing isn't exactly one of the arguments you turned in. It's derived from 1 or 2 of the arguments that you passed in. So being able to specifically say, it needs to be this, and this is what I got. And you can wonder how in the world it ever got to that from what you passed, but that's what happened. Yeah.
When and how will I be able to make libc generate these extended errors internally? Like say you pass a negative value to square root, you get en val. It would be nice to add some extra information there saying negative value got passed to square root.
Well, in some sense, you can already do that with, well, no, I guess, yeah, you're talking about in libc itself. That's a good question. I mean, I guess I would hope that libc would be able to produce an error message, but of course you don't necessarily want libc to produce the error message. So
you'd almost need libc to be able to write to the extended error struct with an extra helper function or something.
Yeah. Yeah, we don't yet have an interface to let libc put something into that structure, but that would be, I started to say trivial. It actually wouldn't be trivial, but it would be doable. Just because of the way the current mechanism works. But yeah, no, that would be possible and probably should be done.
What do you do with a thread when you fork?
When you fork, you create a new process. And as part of that process creation, the C library will set up an external error buffer for that new process.
So you get a new thread in the child.
Yeah, each time you create a new thread, either by forking or fork threading, the underlying infrastructure in the C library creates that, sets up that buffer just as part of the overhead of doing that. We chose to make that happen so that it would just by default kind of work, at least for C programs. We didn't add that infrastructure to the other runtimes, like Rust and Go and so on. In there, it goes in the startup code for the thing. CRT0 in the case of C programs. And it should be added there, and hopefully somebody that knows more about those languages will do that.
Yeah, for fork, it's not even like, user space doesn't have to do anything at all. It's just, you have another copy of the process, and the addresses are still the same, and the threads have been cloned, and all that just happens.
Right, so it's actually
just
when you exec and replace it.
Yeah, with exec, yeah, you restart, and then the startup code does the thing, and
yeah.
When you create a thread, another system call happens. I was slightly surprised that Caustic went for an always make the system call implementation.
Oh.
While doing it in the other runtimes is obviously the right way, I wonder if you were going to make it exclusively required that, if you run something under ktrace, I wonder if the ktrace infrastructure could set up the space so that if it wasn't a C-based thing, it could create the space to store the extended messages.
I guess I don't quite understand.
If you were going to monitor the process with ktrace from the beginning,
yeah,
could you put hooks in ktrace itself to create the extended space?
Well, I mean, when you run ktrace, the fact that you start up ktrace means it's going to get the extended error buffer for itself if it makes any errors. But what it also gets back is the extended error message from whatever the process is running. So it says, did this system call with these arguments, return value this, and it then pulls out the error string from that.
But if you ktrace a Go program?
Yes, I see what you're saying. Yeah, I don't know. Yeah, you probably could do that, yeah. I'll talk to Caustic. I'll give him that suggestion. And if it's easy to do, he'll do it. Even if it's hard to do, but it's doable, he'll do it. Yeah.
Are there any restrictions to doing this in like external modules? If you were making, say, a new Mac module, can you easily use extended error messages in it and deal with the fact that it's loaded dynamically?
A new Mac module?
Just any kernel module. Is there any restriction on using extended error message there?
No, I mean, as long as it's got the, it's compiled in, it's got one of those values at the top and the include that it needs and uses exter, then it'll have it.
Seems like we might need to namespace to alter the namespace with a file named thing. Because otherwise,
well, the thing is, as part of that thing where I said you had to create a new entry,
yeah,
that's an arbitrary name, and you just make that name up.
Yes,
and
but
it's a unique number.
If you're an external module,
yeah,
then how do you decide what number to use?
You just allocate one in that file.
Again,
and it's just dedicated for you. No one else is ever going to use it.
An external module that does not ever interact with FreeBSD, except by being compiled and loaded.
Well, then it wouldn't have that include file. So
yes. Well, so if like a module, a proprietary module.
Okay.
So so we need to figure out how we're going to handle reservations there. And I wonder if we should be using linker sets instead of something involving linker sets instead of hard-coded numbers.
Right. Well, unfortunately, we pretty much depend on those hard-coded numbers to tell us, which file it's in. And
yeah, and I'm wondering if that was the right design decision.
Yeah.
We should think about revisiting it because I think code that's not part of FreeBSD is, I think, going to be a problem. We could also reserve a bunch of numbers, but
Yeah, actually, that's probably the thing to do, like we do with system calls. We reserve some system calls for those kinds of things. So we could just reserve a batch of numbers. We'll give them the negative numbers.
well, it's got to be an array. Well, the
Yeah,
array
that's
is a little
true.
awkward. We need some indirection, and we should
Yeah.
probably rethink it.
Yep.
I didn't like that part in the first place.
Okay, any other questions? Going once, going twice? Done, thank you.
Brooks Davis with Capabilities Limited, and I'm here to talk to you about Cherry and bringing memory safety to BSD operating systems, FreeBSD in particular, using Cherry. So, first question, of course, is what is Cherry? I apologize for everyone who has seen this slide before, but I know not all of you have. So, Cherry is a processor architectural protection model. It composes capability system ideas with hardware and software, and does this by adding new security primitives to the instruction set architecture, which are then implemented by the CPU and the system-on-chip memory controller, all those bits. And with that, it enables new software behavior. In particular, and one of our key focuses from the start was protecting C and C++ trusted computing bases. So we provide memory safety to those systems. So that's like kernels, hypervisors, operating systems, all the things that are going to be in C and C++ for the foreseeable future, even as parts of them are rewritten in things like Rust. Beyond memory safety, it also enables scalable compartmentalization. So extremely fine-grained compartmentalization at levels really unimaginable with today's process-based isolation. And it's not, well, it started at the University of Cambridge over 15 years ago. It's not just a research project. At this point, we have multiple industrial implementations. You will be able to buy embedded versions of Cherry probably within the next year. So how does it all work? So the key simple idea of Cherry is that we extend integer addresses that are used as pointers, and we add metadata to them. We add permissions, we add bounds, and a few other things. We also add an out-of-band validity tag. Without this tag, you can't use a capability to access memory. And if you make it, so if you make any manipulation that's invalid, or if you take the pointer way out of bounds, the tag gets cleared. Also, if you do a conventional store over that capability, so you write bytes over it at a classic buffer overflow, the tag is cleared. So you can only create new capabilities from other capabilities, and you can only make capabilities with less permission from another capability. This gives you provenance validity and monotonicity. All this adds up to a system that lets you, with a bunch of software help, implement memory safety. So how do we do that? Well, in C and C++, we replace integer pointers with Cherry capabilities. And that means that we adjust the size of structures. Pointers get twice as large, and they now have to be strongly aligned at 128 bits. But for the most part, that's kind of it. You do need to manipulate them correctly, so some historic idiomatic C things like XOR linked lists no longer work. But essentially, you only really need to add clarity to your programs to make Cherry work. And then there's a bunch of parts. So like, for example, when the kernel hands you memory as a process, the kernel needs to give you bounded pointers to the address, to the space that mmap allocated. Likewise, we need to modify our malloc and other allocators, runtime linker and the like, to put bounds on pointers that are handed out. And that's all relatively straightforward. And then, in addition to this modification of explicit pointers, making them bounded, we also bound implicit pointers. So there's a bunch of sub-language pointers, so things like return addresses, entries in the global offset table, PLTs and the like, your stack spill, things that are spilled to your stack automatically. And we also make those capabilities. It's particularly important for things like return addresses. It means that even if the compiler screwed up and allowed you to have a buffer overflow on your stack, you would be overwriting a capability. So if you wrote a string over it, it would no longer be valid. So there's in fact a defense in depth here in the design. One interesting thing that we were talking about recently is, in fact, Cherry assembly is, in a sense, with certain restrictions, a memory-safe language. You have to think very carefully about what that means, but it is, in fact, we in fact provide defenses even at the assembly level if you are doing the things right. So if you have your bounds on things that you've passed to some assembly, the assembly can't escape. So it's really protection throughout. So I'm going to say, so you might say, well, it sounds like you need to change your code, you need to do that. That is true. There's a fair number of changes. In FreeBSD, there's a couple percent lines of code change in the kernel. But we can also do really big things. So an example of something that we took on a few years ago is Chromium. It's a grand challenge application, really, for any kind of memory safety technology. The base code, as of the snapshot we're using, about 27 million lines of code. There's 7 compilers, 6 of which are just in time. Once you add in the library dependencies, you're looking at about 47 million lines of code, and like nearly 800 libraries, many of which are just statically linked into the giant binary. And then the V8 runtime itself, about 2 million lines of code, doing all manner of horrifying things. It's a JavaScript runtime. And then, the code comes from everywhere. This is not like Google sat down and wrote all this code. No, they downloaded half of it from the internet from random people. And then they put it all together. And they've applied engineering to it, but nonetheless, it's the classic supply chain disaster here. So it's quite fun from a retrospective purpose. We started in, I think, 2024, and we have a snapshot from then. We're currently updating it, but we have this nice snapshot that works reasonably well. So we could examine what happens as new vulnerabilities come out since then. And thankfully, there's a wealth of them. Even before the current LLM-generated bug boom, there was a critical remote execution vulnerability about every 2 days in Chromium. As Robert likes to say, first of all, your browser always seems to need an update, and also, you should definitely click that update button, because it's almost certainly an RCE, possibly a zero-click. So let's take a little detour and do a demo. So first, I will show you a bit about this system. So I'm working on this Morello box here. It's an ARM Morello box prototype running Cherry. We have a Cherry BSD kernel. It says FreeBSD, because if you change that name, all the autocomp scripts stop working. And who has time for that? So we're running a generic Morello pure cap. That's a pure capability kernel where every pointer is a capability. And let's see, let's go ahead and do a proc-stat-a, and we'll take a look here. So, my window is too, I need a smaller font. Oops. It's not going to cooperate. Let's do a new tab. Make it slightly less big. There we are. So in this column labeled emule, which should be ABI or something, really, normally it would say FreeBSD ELF64. You'll notice everything here says, except the kernel processes, say FreeBSD ELF64C, which means Cherry processor, or a Cherry ABI process, pure capability. And you notice currently everything, including Chrome, is a Cherry ABI process. Now we'll look at some Cherry output. We'll just look at the end here. This last column is labeled C18N, which is compartmentalization. It's a number of compartments we're running. Current Chromium is, now I'm blanking on the name, but it's compiled with most of the libraries compiled in. So there's only a modest number of support libraries, 100 and 110 support libraries that are linked separately and have their own compartments. As opposed to if you compile it as a component build, you would have 700 or 800 of them. And all that just works. Likewise, the Ocular PDF viewer I've been using there. Let's take a quick look. We have many web pages work. I think the PDF viewer worked last time, although I haven't checked it on this build, so I'm not going to check it now. But perhaps more importantly, we have a, oops, it would help if I was not on the Cambridge website. There's no exploits directory on the Cambridge website. People get cranky when you put exploits on your webpage, especially when you have government funding. So we're gonna take a look at one exploit here. So this is, okay. Title is not showing today. Anyway, so this is a vulnerability commonly known as BlastPass. However, when we go talk to people who make browsers or we talk to their security teams, they see this number and they wince. Because for both Google and Apple, this was a bad month. This was when they independently discovered this vulnerability, because errors and miscommunications in the vulnerability reporting process, it was a zero-click SMS vulnerability. Because image preview, whoops, bam. So it's a vulnerability in the Huffman coding bits. Like Google wrote the WebP library, so it was a first-party thing for them. They did all their usual engineering. They did all the fuzzing. The fuzzing didn't get deep enough into the Huffman coder. And so there was a simple buffer overflow in the bottom. You just had to have the right big enough inputs and zero-click fun. So we can go ahead and load the malicious WebP. I did have to, on this box, reinstall the defective library. And here, we got a crash from Cherry memory safety violation. So your page died, but you were not exploited. If you click this on an ARM, if you click this in a basic ARM binary, you overflow the array. If we did more work, we could take over your machine. And NSO Group did take over some people's machines. So let's go ahead and hop back. And that's kind of an example of what Cherry can get you. Now, so there's that. So BlastPass, naturally occurring vulnerability. It's a nice example of the sort of things we do. We also took a look at, this is now a couple years ago, there was the AIXCC Grand Challenge at DARPA. They had a team of security experts introduce vulnerabilities or reintroduce vulnerabilities in open source code and then give them to teams to apply various, whatever AI they wanted to find and fix the bugs. They didn't know about Cherry, and we didn't know anything about them until one of the participants told us about this contest. And so we took a look at an Nginx where they added 14 memory safety vulnerabilities. And they also provided ASAN reproducers. So we said, okay, let's see what Cherry does. So we did. We looked at them, except for one that uses a feature not implemented in FreeBSD. We mitigate all the vulnerabilities. The ones in light green are temporal safety vulnerabilities where it's not obvious. The other ones, you look in the debugger, you're like, yep, the buffer overflow failed. In the temporal safety vulnerabilities, you have to think a bit harder about whether you actually mitigated it, because our temporal safety system allows a window where you can still write to the bad buffer, but it can't ever be reused. But in any case, we managed to mitigate all these vulnerabilities. In addition to that, while we were fuzzing the system with Cherry and ASAN both, we discovered that one of the vulnerabilities, well, it had an ASAN reproducer, was a sub-object bounds violation. So you didn't actually have to overflow the object in order to exploit it. So that was interesting. So even a sort of a very basic memory, so you could run with ASAN in production, which would be very slow, but you could do it, and it still wouldn't have protected you. And likewise, a technology like MTE wouldn't have protected you. And we also found 2 more that they introduced. We asked them, they did not mean to. It turns out that experts writing C code and employing fuzzing still write these kind of dumb bugs. So the bottom line is we found 114% of the vulnerabilities in this software and defeated them all. So that was fun. Now for something a little more current. So the very first LLM-generated and exploited bug report that came into the FreeBSD project was this RPC-sec GSS bug. I think the interesting thing is, conveniently, it was one that we did trivially defeat. It's a very straightforward buffer overflow, so Cherry would have solved it, so that was nice, and that gave us a little hope that the AI wave will help us get Cherry adopted. I do, however, want to not overpromise. It's important that you not overpromise when you're trying to get technology adopted, because people then think you're a liar and they don't trust you. So I took a look at this week's, or the last week's batch of security vulnerabilities. Ones in green are things that it's pretty obvious that we would have defeated. The ones in yellow are temporal safety things where if we had kernel temporal safety, which we do not yet, but we have some prototypes, I think we might have. And then there are some where, especially some of these compound ones, where it's upgrade unbound and there's a pile of them, upgrade OpenSSL and there's a bunch of them. We mitigate many of them. So I say it says fairly typical, sort of a fairly typical spread in terms of looking at past kernel vulnerabilities. It's a mix of logic bugs and memory safety bugs, and this has held for quite a long time. I'm kind of wondering whether we're going to see a trend towards more logic bug discoveries with LLM bug finding. I suspect we will, but who knows? It's early days. In particular because anything Cherry can fix, it's almost certainly the case that fuzzing could find it. So we have existing techniques that should be finding those, whereas fuzzing's much less likely to find logic bugs. Or at least it's harder to tell that you've run into one versus, whoops, we smashed the end off an array or whatever. I will say, though, that this analysis is like me spending an hour yesterday, so it's very minimal. Whereas the previous analysis, we had one of our people who does offensive research write a proof of concept and get to the point and really demonstrate that we defeated it. Whereas these, it's like me looking at it and going like, yep, we probably defeat that. So one thing, you might say, well, all these benefits are nice, but do we have a transition path? How do we get there? The answer is, with Cherry, we can run legacy applications side by side. We have the ability to, rather than having, to rewind, with Cherry, every memory access is via a capability, one way or another. There is, however, a legacy mode of operation where we make integer addresses be via a default data capability or via the program counter capability. If you set them to the whole address space, then it works just like before, and there's really no effect. And in fact, on most CPU designs, unless you turn Cherry on, the arithmetic bits don't even get engaged. That's powered off. So it's quite effective. So it's just as if Cherry wasn't there. In Cherry BSD and in our FreeBSD adaptation, you'll have the ability to run ARM or RISC-V binaries side by side with Cherry binaries. So what's available today? So in limited quantities, there are these ARM Morello boxes. They're definitely a prototype architecture, and they're not going to be the first thing to market. What is available today at more than just QEMU is we have at Capabilities Limited developed Cherry CVA6. CVA6 is an open source RISC-V processor under the Open Hardware Foundation. I think it's from ETH Zurich originally. And we've added Cherry to it. We have contracts currently with Low Risk to bring it to production quality, targeting security processors on larger system on chips. But we're also making sure that we have a useful platform in conjunction with the University of Cambridge to let it run like a conventional operating system, and working pretty hard to make it, computery. So you can have a board, and we hopefully be in a situation where you can stick a USB installer in and install on a NVMe, and not be this embedded crap where you're, trying to load stuff over JTAG or whatever, which is, as a software developer, not what I want to spend my time on. So we have this available. The board's about $1,000, so it's not crazy, but it's not free. Okay, so if you want to learn more about Cherry, the link to at the top to the Cherry Research Center, cherry.cst.cam.ac.uk. There's a nice summary article in a special issue of IEEE Security and Privacy magazine last year, which won best paper in that magazine. And then we have an introduction to Cherry on our website, Cherry C and C++ programming guide. For that one, I highly recommend using the web version, not the quite old PDF. And then the ISA specification. We have a Cherry ISA v9 is our latest tech report. It's several years old now. It's synchronized with early RISC-V work. There's also the draft of the RISC-V Y architecture, which adds Cherry to RISC-V. It's undergoing ratification, hopefully in the next month or two. We've been saying that for a while. Turns out Cherry is probably the biggest thing that hasn't already been commercialized on some other ISA that RISC-V has ever done. And so it's taking time, and it takes a lot of reviewer bandwidth to really get through it. But I hope we'll see finalization fairly soon. At this point, we have opcode space that we're pretty certain is final, and I think mnemonics are probably close. So we're getting there. We'll have to see. So now I'll talk about upstreaming Cherry to FreeBSD. So our goal is ship FreeBSD 16 with at least Cherry temporal safety support. Or sorry, at least Cherry spatial safety support. Temporal safety, we'll see if we make it or not. It's a more complex, and there are more trade-offs involved. So why upstream? Well, I think FreeBSD needs a memory safety story. I feel like, well, virtually all operating systems lack any sort of credible memory safety story today, unless they're a from-scratch thing that's still tiny. That's not going to remain acceptable forever. Governments are not thrilled about the constant stream of vulnerabilities and the current state of affairs. And while memory safety doesn't solve every problem, it is a problem we know how to solve. So it's a bit sad that we haven't. But, rewriting it all, not very practical. Some people are like, we're going to rewrite it all with AI. And we have varying degrees of skepticism about that claim, but I think that's unlikely to happen in most cases. Besides, I think, actually, many of us are weirdos and like C in some ways, even though it's terrible. So, I'd like to continue to have this option and continue to use the code base we've been building, because it's actually quite good and powerful and useful. By bringing Cherry support to FreeBSD, we reduce we reduce the risk when somebody wants to adopt it, versus a research OS that, we try pretty hard to keep things stable and useful and productive, but, and we have worked very hard to support upgrade to upgrade, version to version upgrades, but we do break the ABI with some frequency. So we want to bring that, bring stability and credibility to the parts that are really ready. and provide sort of a production OS with really proven features. Some of our ideas have been great, and some of our ideas have been not so great, or simply not well baked. And I would say one other benefit to the community overall is that generally speaking, outside of places like the runtime linker, most of our code change is really about improving the clarity so the compiler can correctly implement what the programmer meant. And sometimes when we look at classic C code, it's not actually clear what the programmer meant. And it turns out it all works because it's just a bunch of numbers, and we all mush them together and do crazy things with them. And it all works out all right at the end as long as there's no concurrency and you turn off a bunch of optimizations. So Cherry really does improve intent, the expression of intent, fixes a lot of things, or generally improves things. And also, it turns out Cherry finds general bugs that apply outside, to apply to all software. So we found, a modest number of long-standing buffer overflows or buffer overreads in a number of cases where, in practice, nothing bad happened, but that's not to say that if you recompiled with a radically different compiler or you reshuffled the code a bunch, that now it wouldn't turn into a bad thing. So we fixed a bunch of bugs, and actually, I find a number of developers will start using Cherry and keep using it even though there's not a product yet because it helps them find bugs. I think Cherry BSD gives FreeBSD and really I think other BSDs a lead relative to say Linux. There is active work going on bringing Cherry to Linux, but I think we have a significant lead on features, and I think generally good community acceptance of the core ideas. So I think we're going to have a shipping product. We should be the first real significant OS to ship with some Cherry support. So what are we upstreaming? Well, we're going to upstream support for the RISC-V Y standard, RV64Y, aiming for a tier 2 architecture. And there's hardware on the way. We've got some hope of some nice kind of Raspberry Pi type boards in a couple years, but there's nothing concrete yet. But we're pushing pretty hard to get something to happen. And there's also FPGAs available today, as well as QEMU emulation. And then we're also planning to upstream Morello support. Well, Morello as an architecture is a bit of a dead end in that if ARM picks it up, they're going to put it in a different opcode space. And they also, it's a superset architecture. So usually when you design an ISA, you decide how you're going to do things, and you find the one sensible way to do something. With Morello, there were a bunch of cases where we weren't sure. So where it was cheap, we tried all the options. So we have like 6 compartmentalization mechanisms. RISC-V has 1. So Morello will be distilled if ARM makes a product out of it in the future. But the hardware is available, and you get to do cool things like present on it. So we're going to bring support in. It's also something we can provide to the FreeBSD Foundation. We're working on that, making sure the foundation has some boards that FreeBSD developers can use. We plan to focus on pure capability, Cherry C and C++. In Cherry BSD, we support a hybrid C and C++. It was essential to the bring up in the kernel because we initially didn't have any compiler support, and then we only sort of had compiler support, and there's an evolution there. And there are a bunch of interesting things you might want to do in a model where some pointers are capabilities and some pointers are not, but we don't have good examples there, and we don't think it's actually a very good idea. I have on other variants of my talk where I talk about that, I show the classic "it's a trap" meme because it's a trap. You think it's simple, you think I'm just going to annotate a few pointers and I'm going to get some security benefit, and it's going to be great. And then you annotate 1 billion pointers, and you are sad, and your code doesn't merge anymore, and it's terrible. So don't do that. And we're not going to support it at all in FreeBSD in the initial version. If it turns out there's a use case, we'll figure it out. And we know how to do the basics. But for now, it's going to be it's going to be either legacy or pure capability. And then the kernel support is going to lead user space. It's for the simple reason that you got to have a Cherry-enabled kernel to run a Cherry-enabled user space. Also, there are benefits to just having a Cherry-aware, a pure capability kernel. You even actually get some protection. You provide some protection against confused deputy bugs in the kernel to user space. So let's see. So overall timeline in terms of patch production, which is not the same as committing them to FreeBSD. This is under the project that I'm funded on. I have a timeline, and it's for patch production. It's not for upstreaming, but I'm working on upstreaming. So through March, we were working on getting pure capability kernel support. We've turned a few things off to get to that point. Few subsystems that I didn't feel like pulling the patches in yet for a variety of reasons. But we got there. We had both Morello and RISC-V booting in March. We're now working on user space support. I'm currently through all the libraries and into the runtime linker. And the runtime linker is big and complicated. And we also, one of the challenges of this project is that we have things where we have parts of the code where we've got multiple projects impacting them. And we only want to pull in the things that are relevant to FreeBSD. So I need to pull them back out and get them merged. So we're working on that through September. I hope by Euro BSDCan I will have a pretty much fully functional FreeBSD system, at least in a VM, or in a or possibly even running on FPGA to demo. After that, we're working on linker-based compartmentalization. That's something we're doing as part of a DARPA program. In particular, in addition to placing compartments around every library by default, we also have the ability to carve up a single program or a single library and add compartments within that. And I'd like to at least have enough of that in to for instance, isolate mmap, or not mmap, malloc from the rest of libc. So the very powerful capabilities to all of your heap are not available if there's a bug in, a string parsing thing in libc. And then after that, we'll work on heap temporal safety. The latter two are much higher risk. I think the first two are really low risk, although there's a fair bit of change. So progress to date. So here's a snapshot of running in a VM earlier today. Again, generic Morello kernel. It's a pure cap kernel. Just doesn't say pure cap because that's redundant in FreeBSD where I'm not going to upstream hybrid. And then we have two supported architectures. We have both AArch64 and AArch64C, which is the capability-aware version. Currently, we've got about 450 patches to commit. I've got, I don't know, 60 in review at the moment. I'll talk a little more about those in a minute. And it's a fairly big change, but it's probably, to put it in perspective, the machine-independent parts of Cherry support are about on the order of the RISC-V of RISC-V support. So it's kind of like an architecture. So it's big, but it's not like some monster million-line crazy thing. So I'm going to go over a couple of tidbits, technical tidbits about the updating process, things I've been working on, and things that I have under review. So in a capability system like Cherry, there are two principles that we like to follow. First, the principle of least privilege, that you should run any bit of code with only the privilege that it needs. And the other is the principle of intentional use, which is a newer idea that dictates that when you have multiple privileges, you should pick the one that makes sense to exercise. So even if you have, the whole object, you should use, or a whole array, you should use the actual individual element that you care to manipulate. And this whole idea of intentionality sort of imbues the port. So one of the things we want to do is we want to make it clear whether or not we should propagate capabilities when we copy things. So we might be, if we're copying to or from a disk, we should not be copying capabilities, and we should in fact prevent that from happening, because it's a bug if that happens. So I've added a set of explicit provenance APIs, or I've got reviews for them. In the case of memcopy and memmove, they copy by default because they have to, because the C standard pretty much, well, C implementations require that memcopy be able to copy any object. We have a data version, though, if you know that you aren't copying. It's mostly used internally in the kernel, but rather than as an explicit thing that most programmers would use. It's mostly hidden in other interfaces. And likewise, for copy in and copy out, most of the time you're doing things like copying buffers. It's actually more than 90% of the time there's no pointers that you would want to transfer, so we want to make sure you don't. It's particularly important on copy out, or we would like to not accidentally leak kernel pointers into user space. So another, oh yeah, I just wanted to mention, I've linked 2 reviews here. It's actually a stack of 6. So if you're reviewing, review them all. Another tidbit, of course, I said we could run legacy software, and we can. We added a FreeBSD 64 compatibility layer. It's inspired by FreeBSD 32, but it's actually totally different. And the reason it's totally different is that in FreeBSD 32, you're dealing with size changes in objects, or type changes in objects. So, long goes from 32-bit to 64-bit. Time T is 32 bits on i386 and 64 bits elsewhere. Offset T gets split between registers, things like that. Whereas in FreeBSD 64, structures generally remain the same unless they have pointers in them. But when we do copy-ins and copy-outs, they have to be via capabilities, not the integers we get from user space. So we have to have a wrapper function that allows us to, gives us the opportunity to create a capability that we then use. So I'll give you an example here. Conveniently, it's aligns, if you were in Kirk's talk, it uses the xdir control function because it was easy and I had just done it. So we add a new kern version, or a new kern xdir that we call from sys xdir, and it takes a pointer argument is a capability from user space, and we just pass everything through and it's all fine. There's no real, that's like the whole change. To add FreeBSD 64 support, we then have to call, and then we use these user pointer macros to create a bounded capability, or an optionally bounded capability. There's you can compile it with or without bounds, but basically it derives a capability from the default data capability of the caller. So pretty simple, pretty straightforward. There's just a ton of places we have to add these. So I have a review pull request up in GitHub with about 50 files changed, 50 files changed to add all the missing wrappers. It's 100 and something of them. So, and one final tidbit, so actual commands are sort of declared as a group, a number, and a type, which encodes the size. Usually, either the size doesn't change at all between architectures, or it changes because there's pointers in it. Struct ifrect is really weird, and it has a union, which has pointers in it, which means we need to do special handling. But the size doesn't change in between 32-bit and 64-bit. So we didn't have code all throughout the system to handle that. With Cherry, the size does change, the union grows, and now we have to add a bunch of cases. It's all over the place. So I added some sort of funky case macros that I'll be deploying to handle that. because most things don't require any special handling, because the union is, there's some non-pointer type in the union, and you can access them in an accessor, and they're just fine. It only becomes a problem if there's no accessor, if there's pointers, but the size changes. So that's kind of weird. A few words on the get strategy we're using, since I'm hoping I'll get people to help review. There's a lot of review, so I don't want to burn anyone out. So we have a fork of the FreeBSD source repo under the Cherry Alliance on GitHub. We have a main branch, a CI branch. It's supposed to be a CI branch. Something broke a while back, and I've been under deadline, so I haven't fixed it. And then there's a Cherry branch, which adds all the bits of Cherry. Patch readiness varies wildly, and it's definitely not a thing you'll want to run. You'll definitely need to talk to me, and I'll have to give you large command lines. But it is there. There's code to look at if you want to. And then I'm starting to submit patches or pull requests or patch groups through Fabricator or GitHub. I might try the Forgeron instance, but I haven't yet. And so, yeah, as well, some patches such as John did a bunch of changes to VM APIs to disambiguate between things that took pointers and things that took integer arguments. So he's changed a bunch of the things that where there was confusion to use void star pointers, which ensures that you stay functioning. And also that there are compiler errors if you get it wrong, if you have an old module out of tree or something. So encourage people to get involved if you're interested. We're broadly confident in our overall approach, but more eyes help. More eyes also like slow me down, but it's all good. You know, I pushed some proposed changes, and Ed had some good suggestions, which I've then created more pull requests for over the last couple days. So that's good. I think in Fabricator, things are going to end up tagged with #cherry, which you can follow if you want to. And then I'm overall tagging commits with this effort cherry upstreaming, so you can watch them. And I can find them later to tell my sponsors good things. So yeah, you know, if you're running a different BSD, talk to us about adding cherry support. It'd be cool. I'd love to see more of us doing that. And I suspect there are funding sources we can't easily tap that other people could, for instance, European funding. So, any questions? Yes, and got to get a runner.
Hi, thank you. This is only sort of tangentially related to your talk, but what security mechanisms prevent non-cherry instructions from running if you're in a cherry pure capabilities mode?
So in both RISC-V and Morello, there is, one way or another, a mode which says which mode you're in. So all the load and store instructions, which take up a ton of encoding space, are generally either capability instructions or they're integer instructions. And if you're in the mode, you do the appropriate thing. So in Morello, they did the thumb architecture thing where they set the low bit. In RISC-V, there's actually a separate mode bit in the program counter capability that's there. So completely malicious software could change it, but in a pure capability program, your default data capability is null. So if you go in integer mode, you go bang once you do a load or a store.
Okay. And then also, based on how the hardware development is going currently, do you foresee regular consumer devices having cherry-enabled CPUs within the next 10 years?
I certainly hope so. I hope that we will have dev boards in, say, 2 to 3 years.
Cool.
I think there may be, and there are embedded products which use a RISC-V ISA called Chariot. They're 32-bit, single, no MMU, sort of Arduino class CPUs that are, they have first tape out They have some bugs to fix, but I think they'll be orderable within a year. Mark.
So apologies if you mentioned this and I missed it, but is there any, have you thought about the ports tree at all? Like, will it be at all possible or even easy to build ports against a cherry target?
I mean, so we have a Cherry BSD ports collection. It is from 2014, I think. So we've done a bunch of adaptation. There's a bunch of patches which we're trying to find time to drag forward. Like the basic things to be able to do it aren't very hard. Right. The basic infrastructure bit. So I didn't ask for funding for it because it seemed unbounded. But it's definitely something I would like to do. I want to get working. And the question is probably how best do we make that possible?
Like I would kind of selfishly want to start by trying to enable all of the ports that you need to build in order to run the full regression test suite, for instance, which is like, there's a bunch of things in there, but it's not, you don't have to build Chromium or anything like that.
You don't have to build Chromium, but you do need what, Perl and Python and
Rust.
Well,
but you just need, so in a lot of cases though, they don't need to be pure cap. Like they're just standalone programs that you run as part of the.
Yes, so I guess one complication there, and so on Cherry BSD, we did this slightly evil thing where the package binary just prints a message saying use these other package binaries. And so we have a package 64C and a package 64. Package 64C installs things in sort of in user local. Package 64C, or package 64 rather, puts things under user local 64. I did it, there's an argument we should have made them both special, but changing local base breaks enough things that I wanted to give pure cap every advantage. So there's a challenge there in trying to, because you have to install the same package for both of them sometimes, and so you have to separate them out somehow. And I don't think our solution is like the right one, but it does work in a sense.
Yeah, thank you very much for the talk and for your work. And apologies if I missed it, but I'm curious, for the Morello and RVY architectures, do they both have the same approach to temporal safety in Cherry? And if so, is that the state of the art, or has there been additional research to kind of address some of the pitfalls you talked about in the DARPA competition?
So they both have the same approach, fundamentally. We have an approach that we introduce a load generation, and we use that to be able to, we enter a replication epoch, we scan all the threads, and then we flip the generation, and then that means that there's no way to get an old capability without triggering a fault that allows pages to be scanned. And then we do a background page scan. The things, so there is some interesting research. There's some possibility that we could use MTE to be able to at least not have to immediately quarantine on every free. We could say quarantine every 14 frees would be one option. There's also a bit of work at Ericsson. They have a paper on colored capabilities that would allow you to basically do the same thing, but with many more bits. So like 20 bits. So you delay quarantine for quite some time, which helps, and it does give you immediate revocation. It's not clear to me whether their model will scale to a large high-performance CPU, which is also a cell phone. Certainly in a single core threaded, a single core environment on a single CPU is likely to work.
Thank you.
Does the hardware include other security features as well, such as no mutable memory for firmware?
That's not an explicit part of Cherry. There's no reason you couldn't do that.
Right. I'm asking whether the prototypes plan anything like that.
I don't know of anything specific. I mean, firmware is usually often loaded separately. I don't know if, I don't know if, for instance, SCI's Iceni has fusible memory for firmware.
I mean, presumably on RISC-V, that's just a PMP, right? If they use a PMP to protect their M-mode firmware, but I don't know if they have that or not.
So Chariot definitely removes the PMP because the PMP is basically the same area as Cherry, and people care a lot about area. So you get rid of the PMP, which is mostly useless, and replace it with Cherry.
It's true that with Cherry allows you to subset your address space anyway. So as long as you're not handing out any capabilities, so like your M mode could already restrict the capabilities that it makes available to anything else. Like if you have S mode, for example, you could ensure that any capabilities you hand off already exclude whatever you want to protect, which is kind of equivalent to a PMP. I'm not sure exactly if that's what they're doing, but yeah. I mean, most of these things probably run in M mode all the time, but you can still, by subsetting your address space, you can effectively have memory that is not accessible to the application parts of your system.
I mean, early enough in startup, you could in fact permanently discard privilege to some things.
Thanks.
Over there.
Have the OpenBSD folks talked to you at all about any of this? It seems like something they'd be interested in.
I haven't talked to anyone who's been excited about porting yet, but I have talked to people who think it's cool. So no one's jumped on it. I kind of think actually like going after EU funding for them might be a sensible approach.
So I haven't looked very deeply at the Morello architecture subset, but does it support hypervisor mode as well? And then is that currently supported in Beehive? Okay, excellent. Yeah, thank you so much.
Yep. Yeah, we have hypervisor for Cherry to run Cherry-aware operating systems, and we don't have that yet for RISC-V because that's not currently included in Y. We are pushing to try and make sure that gets done before the first sort of consumer available hardware is taped out, because I think it's pretty essential. Like, we know how to do it, we just, like, there's details. So we gotta work them out, do a prototype, make sure it actually works. One of the experiences we've had in the RISC-V standardization is really important to make sure we take all the features that they want to implement, make sure we have Cherry BSD running on the prototype implement hardware to make sure we can actually implement the things. Because some of the first suggestions for some things were not going to work, and that would have been very sad. So I think we are nominally over time, but I'd happy to take another question if there's maybe one more. All right, thank you.
Hello, everyone, and thank you for attending at my talk. Can you hear me? No? Yeah? A little bit louder? Okay. Thanks for coming to my talk. My name is Lukas, and I am a sys administrator, and I will talk to you about using PackageBase in production, a practical overview. I have been using PackageBase since almost 2 years on production systems. And yeah, that's before the technical preview in 15.0. And I would like to give you some insight on how that went and how to actually use PackageBase. I have uploaded some documentation and the slides for this talk to packagebase.de, so you can follow along, or also I will do some demonstration. The commands I used there will be also there. What I will talk about is what is actually the PackageBase stuff. I would like to show you some example network which represents something like I'm using at work, and coming to why I am using PackageBase to build my own packages, distribute them in that network, and yeah, then we will get into the demonstration with converting existing hosts, patch level updates, minor updates, and major upgrades. And if we have time left, we will also tap into jail creation and how to upgrade package-based systems from 14 to 15, because that's not actually officially supported. What is that package-base? With PKG, you now can update your base system. That is because the BAPT has started this in 2015 at the BSDCan in Ottawa and pitched that idea. It took some time, but now we are at the technical preview, which allows to package the base system into some smaller packages, 495 to be exact in the 15.0 release. And this enables to create minimal system setups for installing just the stuff you need, or maybe removing the stuff you don't need. This might replace FreeBSD update in future versions. I have not wrote that it will replace it in 16.0 because I said that last year at the EuroBSDCon that it will replace FreeBSD update in 15.0, which turns out not to be true. Okay, you heard you heard it here. It will be in 16.0. Yes, I will come to that later, but yeah, that's true. So talking about package sets, one thing I especially liked about the 15.0 release of PackageBase is the package set methods. So you can install just the package set minimal, which is about 60 packets, which gives you a very lightweight system with just the bare minimum you need to run a multi-user system. I prefer to install SSH on top of that, but if you don't need it, why bother? There's also the minimal jail option, what gives you a 42-packet jail system. There are some other sets which I won't get into too much, but they are a little bit larger. I especially like the minimal and minimal jail option because for my setup, it turns out minimal plus some few packages are enough. So let's take a look at the network used at work. We do have a setup like this, which is composed out of security layers. So we have an internet connection, and there is a network connected directly to that internet. The hosts in that network are able to talk to the internet and use all of the stuff like you normally would probably need for a simple network. But we also have an internal network which is not directly connected to the internet. There is a firewall between both networks which limits what network traffic can go through or can't. And internet access is not allowed there. So I was looking at the options on how to update FreeBSD systems there. And of course, FreeBSD update is not really sufficient for updating without an actual internet connection. The second option to build the base system or run install word, etc., seemed at that moment a little bit too technical for me as a first starter on FreeBSD. So I was looking into the package-based option, which was discussed a little bit, but there weren't much resources back then. And I actually adopted it and now use it for almost 2 years. For achieving that, I think I will go back one slide. I am using a build server which builds the packages, which is connected in the internet connected network. So I can fetch all the base, the source repo, build packages on that. The build output that I then copy into the internal network via a secure way and publish it via Nginx so every host there can access it. You might have other reasons why you would like to build your own packages. Maybe you have a lot of servers or jails or VMs or whatever, and you don't want to use your internet connection every time. Maybe for building your own source stuff into the packages, or even maybe if you have a slow internet connection, you might build packages yourself because you just need to do it once and then redistribute. To do that, you would need to clone the source tree, check out the release you want to build, build that via build kernel, build world, and build packages, and then I iterate about over the next patch level updates and run the update packages command, the make target. So that I'm only building or only exporting the the packages that actually changed. You could also just build the latest patch level, but then you would end up with more packages with the patch level number in the PKG name, and that would install a lot more of them. There is also a way to build packages in Putria and package-based jails with Putria, but I won't touch that here. I haven't actually quite got it working to get the patch levels right. You can, maybe there is someone who have got it working. I would be interested to hear how that works. So to publish them, as I said, I transfer them to the other network, and then I am given Nginx this configuration to publish it to the network so other hosts can use it. Of course, I would need to configure that repository on the client hosts I'm using, which is done via Ansible in our environment. If you'd like to, and that's what I've done for this demonstration, normally the output of the version is in a folder named 15.0p10. You can actually just use a simple symlink to use the base release 0 URL, which I will show in just a minute. Okay, let's get into converting existing hosts. I would actually recommend using FreeBSD update to upgrade to the 15 release and then use the package basify script. This at the moment requires to install pkg 2.7, which is not in quarterly branch. I think this will not be an issue in 2 weeks because the new quarter will start. But I'm mentioning it here for the full picture. Use the package basify script, which is available on the GitHub repo of the foundation. And this will create or run different steps, like creating a boot environment, changing repo config files, and merging config files with the package default ones. And at the end, restart SSHD. So let's take a look on how that might look. Can you read that? Yeah, OK. So I have installed or downloaded and made the package basify script executable. So I will just run the package basify Lua script. This asks if I accept the risk that comes with it. I accept and create a boot environment because I'm running on ZFS. I would need to say this talk is targeted towards ZFS usage because I don't run any machines without ZFS. I think, especially in the latest releases, this might even run smoothly on UFS too, but I haven't tested it. I will show you how to update using the boot environment, which is a pretty nice way to upgrade, because if anything fails, you can revert back to your version before. OK, package basify is done. So let's restart the system and wait until it's back up. So now we have a package basified system. And I would like to demonstrate the patch level update. Actually, before I do that, this package basified system now uses all the components that have been installed there before. So I would like to remove them and reduce the packages to just the package set minima. Just for reference, pkg info grep FreeBSD set. We see all installed packages. At the moment, there is base, devil, minimal, optional, and tests installed. I only need minimal, and for the presentation, this actually helps me because the upgrades will be much faster. Yeah, so let's remove the packages we don't need. For that, I am force removing the package sets and run pkg auto remove to delete the dependent packages I don't need anymore. Because this is running an SSHD server, I will install that back on the system. And now we're having a system with just info. No, grep FreeBSD. Sorry, yeah. With just a few packages installed. As you can see from scrolling, it's not a very long list. Just about over 60 packets, which will make upgrading a lot faster. Because the package specify script will enable backup libraries in pkgconf, I will disable that just for demonstration purposes, so the pkg list doesn't grow in the following demonstration. Okay, so we are running a 15.0 release, no patch levels installed. So let's get into the patch level upgrades. I would then therefore create a boot environment, as I said before, which I then mount to a folder on my file system. No. Copy. Mount that boot environment. So now we can edit the base configuration in the boot environment to suit our needs, which in my case was just enabling the default FreeBSD base set, and I want to change that to override the URL. As you can see, I am not using the official package-based repos for the reasons of this demonstration, because I want to be not dependent on the internet connection here. And also, I mean, that's what I do on work. I have built my own package sets. Okay, so let's upgrade the boot environment. I use the -C option for change root. If anything fails inside the boot environment, my system is running normally as it would before, and I will be back with no corrupted files or anything. I also can look inside the boot environment for stuff that changed. And if I am done reviewing the upgrade, I just temporarily activate the boot environment and reboot. So now the boot environment will start with the new version installed, which doesn't need me to first install the kernel, boot from that kernel, install then the other packages or the other base system updates, because it's done inside the boot environment by one step. This is a little bit of steps, as you can see, compared to the FreeBSD update script. But at work, I'm just using an Ansible script, automated this, create boot environment, update the boot environment, and also the reboot. So I can step per step reboot and upgrade my hosts with that. Okay, so let's see if it rebooted. Benedict again. So FreeBSD version. We're now running the patch level 10 on 15.0. So let's upgrade to 15.1. I will again create a boot environment, mount that boot environment, and change the configuration inside there. Now the base release 0 means it's the minor version 0. If I change that to 1, I will get the 15.1 release files. Okay, so let's upgrade the boot environment, which is asking me, hey, is that correct? The ABI changed. Yeah, that's, in this case, that's correct. So now I get to see there are some new packages which come from the package set minimal, and the others are upgraded. Let's continue. And also continue by installing, just review. Okay, so for the URL, the default configuration states base release version minor. DCH has created a patch that you can override the version minor flag or environment variable by running env version minor equals 1 pkg upgrade. So you don't need to modify the file for upgrading. So to explain that a little furthermore, we have the 15.0 release. So FreeBSD 15 is in the ABI string, and release 0, the minor version, is the last part. So for 14.4, we would have the ABI FreeBSD 14 and base release 4, and so on and so forth. For current, it's using the base latest tag, and 16 current is the same, just with the 16 ABI. Okay, minor upgrades, we have done that. Let's actually take a look if that is done. We have upgraded our boot environment. So now we can actually temporarily activate it and restart. Of course, after restart, don't forget to activate the boot environment permanently, because if you forget and restart on other reasons, you might end up in your old system. Still booting up, okay. Okay, so now we're on 15.1 release. So let's continue by upgrading to the 16 current release. This is pretty much similar. I create a boot environment, mount that boot environment, and change the configuration to use the base latest. Okay. Now we need to use the, or need to override the ABI. So to upgrade the base system, env ABI equals FreeBSD 16, in my case AMD 64, and upgrade the boot environment. I also specified just the base release repository and upgrade the boot environment using that. So now, of course, all packages are being upgraded. I've built these, I think, last week, so it's not the newest snapshot. Let's install it. And yeah, download it and actually install it. And as you can see, that takes about 6 seconds for the base minimal system, which I pretty like. It's pretty fast. I then upgrade the ports used. So because the IBI changed, we're upgrading ports, of course, which shouldn't take that long. And now we can actually activate the 16 boot environment and reboot. And just in a few seconds, we should be up and running with a 16 current system. And we've upgraded in a few minutes from 15.0 release to the newest 16 snapshot. Let's have a look. Yes. We are now on 16 current. So let's activate this boot environment, bctl activate 16. And we're done upgrading to the newest version, which worked pretty seamlessly. There have been much more problems in the past. Before it was a technical preview, but there has been a lot of work, and it now works, I would say, almost flawlessly. I haven't had any bigger problems. I don't know how that works, or if that all of that works in the current or stable branch, but for me, I'm using the release engineered branches, so that worked quite well. Okay. I'm not too sure how much time we have left. I think it will be just a few minutes until 35. Oh, that's quite some time, about 20 minutes. So let's go into creating jails with base system packages. In that case, I will just create a new ZFS dataset and use the root dir option of pkg to install the minimal jail set. This is actually documented in the jail man pages. If you're using the official repositories, you might the pkg-r might not work because of the fingerprint, but BSD install will work with that. So let's try that out. I think I can't copy that actually. So let's create. Oh, yeah, thank you. I need to stop them and then switch back. Yeah. So ZFS create zroot, because I don't have any other disk inside of this VM. Jails pkg base. pkg-r zroot jails pkg base. install FreeBSD set minimum jail. So as you can see, oh, we're on 16 current. I haven't actually tested that, but let's see if it works. So as you can see, we're installing about 50 packages. Let's proceed. Seems to have worked. So I will enable the jails. Yeah, I haven't. I have a different snapshot of that VM with BSD config installed. So pkg install FreeBSD BSD config. So now we can run sys rc commands. Yeah, I haven't actually documented that. And also install the FreeBSD jail. So then let's create a config for that jail. I hope this is right. That root jails package base seems okay to me. And for demonstration purposes, we will just inherit the IPv4. I will copy my resolve configuration inside the jail so I can actually use it for anything useful. And then start the jail. Cannot start jail, nice. I think I need to put that in brackets, right? No, I have done something wrong. Maybe that's because I'm on Windows and copied something inside there, which should be fine. Jails package base, that seems right to me. Yeah. Okay. I would need to figure out what's wrong here, but I have had it working just a few days ago when trying this out. It's probably some configuration typo, whatever. So that would be enough to start a jail with package base. And the jail minimal, which is pretty slim. So you can also do the usual pkg upgrade stuff with jails, just using the change root or root dir option of pkg. Okay. I would then like to take a look inside what I've done to upgrade FreeBSD 14 package-based systems to 15, which was not quite easy, but I think I got it working. I don't know if that's the correct way, but if it is actually unsupported, though, so I think there's probably the correct way. I am also using boot environments, of course, mounting these and using the ABI environment variable. I will then install the FreeBSD set minimal and set kernels inside the boot environment to only install the stuff I need. Then I will remove everything else that's named like FreeBSD-anything-14.3, where I come from. I haven't quite got why I need to, or something, maybe some dependencies get removed in that process. So I will again install the minimal set and kernels, and then upgrade the non-base packages. This seems to be enough for me to convert my before FreeBSD 15 hosts to 15, and also migrate them to use the minimal set, which I would like to use as least packages as possible, so the system is slim and just has what it needs, or what I need to run. So then after, or before or after reboot, I'm changing the FreeBSD.conf file or repository configuration files, because from 14 to 15, the FreeBSD repo got renamed to FreeBSD ports, and FreeBSD kmods got renamed into FreeBSD ports kmods, so we need to change that in the configuration file. Reboot the system and also change the configuration files that are in the /etc directories, because some of them got overwritten by the pkg install, force install of the minimal set. For me, that's sufficient, because I then can run my Ansible playbooks with changing NTP, server configuration, and whatever, which gives me a system that's usable like before. I think I could do a demo of that, but I think you probably got the point. All of the commands for that are in the demo commands, a markdown file in the link I provided before. So you could take a look there on your own if you want. I also am working on the handbook chapter for package-based, because some of this hasn't been updated since 15. Or I think before 15.0. So there still is some not quite right stuff in there. But I think next week at the Halifax Hackathon, I hopefully can get that out, hopefully get it published. So it is documented in the handbook as well. Yeah. I am installing some more packages than the minimal set, which are these. I'm using jails, of course, but you would probably need to take a look at the available packages on which you actually need or you don't need, or if you are not really sure, you probably can run the base set and probably will be fine. I think we're pretty much done with the time, so I would like to open this for questions, and if there are none, we could then go back into some demonstration, but I would like to give you the opportunity to ask some questions. There's one up there, one up there. Yeah.
Simple-ish question. Do you or maybe someone else in the room know or expect the ability to install a minimal set from the free BSD installer itself, or is this kind of a hack-it-yourself kind of thing if you want minimal going forward?
You can actually use the FreeBSD 15 installer, choose the technical preview package base, and don't select any of the points. So you will be left with the minimal system. I've tested that, and I then needed to figure out how to get SSH on it afterwards, but with the live system, that's possible. Yeah.
Yeah, just a real quick note. I've been on package base for 14 and upgraded to 15 as well. It's worked mostly smoothly. There's one extra step that I have that I needed to do for the packages I have. And we have a Compat 14X, and there's also now a Compat 15X, which is the compatibility libraries for previous binaries. You may need to have that during the upgrade process, or other things may break while doing the upgrade.
Okay, yeah, thank you.
You were using the boot environment there. What about the small machines that are on UFS?
I think, as I said, I haven't tested it on UFS, but I think with the releases beyond 15, that should just work, I'd suggest. As I said, I haven't tested it myself, so maybe try it out on a non-relevant box first. Yeah. Yes.
Have you tried using this process on a jail, and have you had package basify failures, and what were the major causes of those failures?
Unfortunately, I have not that much experience with package-based jails. The hosts I'm running are running jails, but the standard jails, which I had no way of of patch level upgrading before, but I am starting to migrate these to package-based jails with all the 15 stuff, and therefore I haven't had any issues, but I haven't been using it, so unfortunately no. Yeah. Yes?
I wanted to know if you had package basify errors, and if you could tell us what the common pitfalls were.
Okay. The question was if I had package basify errors in jails, correct? Yeah, I have for general package basify.
Yeah, basically, have you been using package basify on a host and it failed? Why did it fail?
Actually, it's quite some time ago that I converted most of the hosts to package basify, to package based, and at that time I didn't use the package basify script. So I had other errors like overwritten master pass WD files and that, but I was using that before the hosts actually get used, so I could set up all of the stuff afterwards. So fresh installation, package basify, and then go on. Yes?
Hi, I had a question. I've been using package base since around 14, playing around. And so from like a full install, I wanted to switch to a minimal. And just like an example, sysrc was not installed. Is there an easy way to figure out which package provides a command like sysrc? Before I have another jail with everything installed, I had to package which for that command.
Yes. That's what I did too, yeah.
Okay. And then I think before, maybe it has been fixed, but I haven't tried for a long time. I was not using boot environments. And one of the problems was, I guess libc couldn't be overridden. There was a change flags issue. I don't know if something has been fixed since then, because I haven't tried for a long time, but I don't know if you are aware of that.
I think I'm not aware because I'm using boot environments, but I have had some issues when testing package-based upgrade stuff. But I can't quite recall what exact issues I had and if I solved them. That's why I am recommended to use the boot environments if possible. Most of that was before 15.0. Yes. Okay.
Thank you for agreeing to work on documentation for this. We definitely do need more good documentation on package base. Please coordinate with Alex about that. One issue that we've noticed is that we tend to have a lot of documentation is spread out in different places, and we are trying to avoid having multiple documents that say different things. So we would like to have documentation in one correct place and everything else pointing at that one correct place.
Yeah.
So yeah, just make sure you work with Alex on that. Thank you.
Yeah, let's talk on that in the hallway afterwards, so I can know where I will be working on next week on the hackathon.
So at the beginning of the talk, Lucas called out if anybody's doing this in Poudre, if they could share. I have that same ask. So is anyone doing package-based builds in Poudre?
I don't see a hand. That probably means no. Maybe I will figure it out someday, and then I'll definitely share it. Okay, I think 2 more minutes left. If there's no more questions, thank you for coming to my talk, and yeah, I will see you.
1, 2, check. Check 1, 2, check 1, 2. There we go. Thank you. All right, everybody ready to get started?
Yeah. We've got 30 seconds to breathe.
Okay, here we go. So, hello. Did everybody have a good time? Good. All right. Let's see what we got here. There we go. None of this would be possible without our sponsors and our team who sponsor with their time and talent. So we're going to take a moment and thank our sponsors. Here's the gold sponsors. ARM. Our silver sponsors, Antithesis, Free BSD Foundation, ISC, and of course Netflix, NetApp, TarSnap, bronze sponsors, Clara Systems, NetBSD, OpenSense, and Saltant Solutions. And of course, our post-conference reception sponsor, Tilted Windmill Press. I got told off for being too loud on the mic at the opening. And of course, we have travel sponsors of Netskommune and OpenBSD Amsterdam. So, and our caffeine sponsor kept us in coffee. And of course, streaming. Thank you very much. Scale Engine. So, and now we are thanking our team of Colin Percival, Alan Jude, Melissa Muth, Andrew Fengler, Adam Thompson, David Maxwell, Albert Deng, Michael Williams, Michael W. Lucas, Diane Bruce, Michael Dexter, Graham Percival, John O'Brien, and John Hickson. Thank you. And of course, Dan, who we will be hearing from shortly. Now, in case you didn't make note, the reception is happening at 6 o'clock-ish, Lux Bistro, and that is the QR code, which does work, I checked. In case anybody wants to, and essentially follow the crowd, and you'll get there quick enough.
We'll get somewhere.
Yes. Now, I'd be remiss if I didn't remind you, the EuroBSDCan papers closes at
Midnight European time.
in 50. See, conflicting information from one table even.
If you feed us beer, we might.
You might get a little wiggle room on the scheduling. Okay. Now, if you will permit us, we're going to have a quick hardware swap, and then we'll have the auction.
So, if you don't know how these auctions work, you're about to find out. Basically, we have a bunch of items at the front. These stacks of t-shirts will be up for grabs at the end, cost you $10 each. Just come down, hand in the $10 to who's grabbing them, to this person here. Give your $10 to that person, and you can take your t-shirts of choice. There's FreeBSD Developer Summit t-shirts. There's t-shirts from 2024 and t-shirts from 2025 BSDCan. Now, I think I'm going to start with Savaged by System D. This is a Michael W. Lucas book. It is not signed, but we can change that. If you've not read this book and don't know anything about it, you really should bid on it, because it is a very funny book. Pardon me? Yeah, it is a full book. All 49 pages. Haven't read it, but I promise you it's a full book. So we'll start at $10. 20? Do I hear 30? 20 going once? 20 going twice? Sold. So,
I bought this for $100 2 years ago. There's been inflation since then. So it's got to be worth at least 125. So I'll say 100, and I want it to go for more.
okay, 100 going once?
Don't make me bring it home again.
100 going twice? 125, yeah, okay. 125 going once, 125 going twice, sold. Oh, where are we putting the money this year? Is it the same place as always? If nobody said, yes, okay. Ottawa Mission. It's going to the Ottawa Mission. All the proceeds from here go to the Ottawa Mission. Yeah, if you've walked down that way, you've walked by the Ottawa Mission. Integrated by Design. FreeBSD from Philosophy to Project. 2026 first edition. It is signed. By Devin? Yeah, Devin Teskey signed it. $20. Ooh, 25? 30? 40? No, it's up to 40 now. 45. No, 40 going, 40. Do I hear 50? 50. Do I hear 60? 50 going once? 50 going twice? Sold. Oh. Sorry. Call out your names so that.
Lucas, that's number 2.
Okay. This is, I'm going to leave the hardware till later. We're going to get rid of the books first. This is also a mystery item. It is a NetBSD sticker on it, but I'm told the contents is not NetBSD related. I am assured that you can get this through customs without any problem. There are no illegal substances in here. They do not need to be concealed. It's perfectly legal.
But don't line it up on one end.
It is a tube. $10. $10 going once. Do I hear 15? Do I hear 20?
20.
Do I hear 30?
25.
No, 30. You do not understand how an auctioneer works. So 20, do I hear 30 anywhere else? 20 going once, twice, sold. Okay, now we're going to do food. This is Farm Boy, pecan and cinnamon granola. It's made in Canada. Somebody found it in the kitchen? $5. What? It is sealed. It is sealed for now. Do you want me to taste it? It is sealed. $5. I'll take it home. This appears to be Colombian coffee? Does anyone know?
It's Viennese coffee.
Viennese coffee.
Fresh from Vienna. Colombian beans, fruity flavors.
$20. 25 going once. Do I hear 30? 30. Do I hear 35?
40.
40 over here. 45, anyone? 40 going once. 40 going twice. Sold.
Raw. That's it. Raw. Rob number 5. Thank you.
Okay. You might have seen this advertised during one of the talks. It's Vince's Hardware. It has the power. Well, I don't know what. GPS receiver. Thank you.
For the time server.
For a time server. And it's time you got to watch. It's pretty much 1,700. So, how much is this hardware worth if you were to buy all the parts?
With current inflation?
No, today to buy it.
Just to buy it. If I went to Amazon, how much would it cost?
All of that combined is at least 100.
Okay, so starting price is $20. 30 over here. Do I hear 40? 40 over here. 50? 50 over there. 60? 70. $100. 120. 150. 160? 170? 200. 210? 210, anyone? 200. Going once, going twice, sold to John Hickson.
Thank you.
This is a grow a moose. You can grow a moose. Put your growing item in a jar or container filled with clean water at room temperature. Watch it grow. Ages 3 and up. Oh. I'll come back. Anyway, okay. $5. $5 going. 10? What? 25. Do I hear 30? 25 going once. 25 going twice. Sold. Yell out your name, please. Alexander. We're going to try the granola again. $5? Anyone? Mine. Sunflower seeds, almond, dried cocoa, pumpkin seeds, pecans, flax seeds, canola, cashew butter. That's as far as I'm going. $5? 10. Do I hear 10 anywhere? Going once, going twice, sold. Yell out your name, please.
Amy, number 4.
Okay, Air Canada Status Pass 1 round trip from Alan Jude. Alan?
So this gets you 3 check bags, priority check-in, priority security, and lounge access on any trip with Air Canada.
Okay, so we'll start the bidding at $50. Oh, come on. Anyone want? 50, you said? What? One? Okay, $50 is the bid at the moment. Do I hear 60? Anyone? $50 going once? $60? Do I hear 70? 70 over here? 80? 90? 80? You do 100? Will you do 100?
Yeah, I'll do 100.
120? Okay. 100 going once, 100 going twice. 120? Yeah,
I'll do 140.
140?
150. Going down, Troy.
So 150? 160. 160? Okay, 160 going once, 160 going twice. Sold to Troy.
Number 8.
We have a power supply. It is. It has. I don't see a name on it. Oh wait. Slim Q has 2 USB outputs and a round thing.
How many watts? Power supply.
It's power supply. Can't read it. It's 120 volts. 2 amps.
Somebody left this in one of the rooms.
Max 150. Max 150 watts. Might be 1500 watts. No, can't be. All right, $5. 10 back here. Do I hear 15 anywhere?
15.
15. Do I hear 20? 20. 25? 30? 30. What? Wait. Are you upping the bid or not? Okay. So it was 30, right? It was 30. 25? You bid 25. Will you bid 30? 35? 35 going once? No, sorry, 30 going once. 30 going twice. Sold. Yell out your name, please. Okay. This is a travel bag. I forget what airline it was. There's a hairbrush, KLM spend, there's some kind of gel, there's a razor, there's envelopes with stuff in it. Looks like there's, I don't know what else. $1. $5, anyone? $1 going once. $1 going twice.
I see a hand up in the back.
$5. Anyone pay $6 for this?
$6.
$6. $7, anyone? Remember, it's charity. $6 going once, going twice, sold. Okay. I was contemplating asking for tongs for this one, but this is a BSDCan 2025 T-shirt. Sorry, thank you, 2005. I'm very bad at math. It has been used. It has been worn a lot of times. This is Henning's old T-shirt, Henning Brouwer's old T-shirt.
I washed it.
So, so on the back, as was custom at the time, was a list of speakers and the talks they gave. So I don't know how many we produced of these, but it would have been probably in the range of 110 to 150. A lot of them are gone by now, I bet. So this is a collector's item and artwork all in one. So start the bid. Sorry? What size? That's very important. Thank you. It's a large. It's a large.
It's truly unique.
Nobody has one like this. Painting?
Will you sign it?
If you want.
I painted my walls.
Okay. Start the bid at $10. Oh, come on. $10 over here. 15. 15 over here. 20. 20 over here. 25?
I'll do 25.
25 over here. 30? 30? 35? 30? 30 going once? 30 going twice? Sold. For this, I have to get out my email to read out the items. So what we have, oh, no, that's not email. We have a ThinkPad T480, Core 15, Core i5 8th generation i5-8350 OU, 4-core, 8-thread, 32 gigs of RAM, 256 gig NVMe, dual internal batteries replaced from iFixit, Wi-Fi replaced with an Intel AX210 Wi-Fi 6, It lived its life mostly docked, screen and keyboard in great condition, well supported in FreeBSD. Mark Felder donated this.
Does he know this yet?
Yes, he does. He handed it to me personally. So this is not a lost and found item, but we have donated, anyway. So this has to go for at least what, $5 starting bid? 5. 10? 15? 25? 30 over here, 40? 55? 60. Is 100 over here? Someone said 100? Back there. 100 over here. 100, no. 110. 200. 210. 220, anyone?
Is there an operating system pre-installed?
I do not know.
Some of the BSD.
So, 220 over here. 230. Yep. Patrick will take whatever funding you have.
256.
256. 260.
275.
275. 280. 300. 350. Did you mean that?
Someone bid 351.
Sorry, what was your bid?
What was that?
What was your bid?
Where were we at?
375.
400. Someone bid 450, but I'm taking you to bid 450.
Well, you should stop bidding.
It's got 32 gigs of RAM. It's a no-brainer.
i5 8350U. i5 8350U. 4-core, 8-thread. 350. 350. No, we weren't. So 400. 425. 425 going once. 425 going twice. Sold. Okay. This is the fourth to last item to be sold. It is 4 copies of the Book of PF. It's the first, second, third, and fourth. 3 editions. 4 editions? 4 editions. It's all tied up in a handy collection of lanyards. So since there's 4 books, we'll start the bidding at $4. $4 going here, 5 here. Do I hear 10? $10? Do I hear $15? 15 back there. 20. Do I hear $20 anywhere? 20, 32 going here. 42 going here. Do I hear 50? Bids at $42 right now. 42 going once.
I just heard they're all signed.
Oh. They're all signed. By the author. 42 going once. 42 going twice. 60 over here. 70 over here. 70 going once. 70 going 80. 90. 80 going once. 80 going twice. Sold. Okay, we're going to have the first of 3 secret auction items. And the way I'd like to do this is we're going to bid it up and up and up until someone gives out, and the previous 2 people that were bidding will get the other 2 items. Okay? So basically, the winning bid gets item number 1, the previous bid gets item number 2, and the one before that gets item number 3. Otherwise, we'll be here for like 3 or 4 more minutes. Okay, For the secret item number 1, we're going to start the bidding at $10. 10. 20? 30? Put your hand up. 30. Do I hear 40? 40 over here. 50 anywhere? 50 over there. 60? 70? Do I hear 80? 80 over here. 90? 90 over here. 100 over here. 110? 120? 130? 140? 150? 160? 160 going once?
170.
170? 200? Pardon? 210? 210 going once? 210 going twice? So, oh. 220. Is that what it was?
It was, he said 225.
Okay, 225. 225? 225 going once? 225 going twice? Sold. Yell out your name, please. Okay, you were 210 for item number 2. And I think you were for 200 for item number 3. That's like $625. That's not for the t-shirt. Sorry?
Williams, were you number 3? No.
Sir, what is your name? Yeah. So that's like $300 for secret items. That's $600 or so. Okay.
Are 14, 15, and 16, so you can tell me which one. In that order, 14, 225, 15, 210, and 16, 200.
That's all the item. Oh, wait. Did we sell the granola? We did. Okay. I think that is everything covered, except for the T-shirt. That? The bag. Oh, shit. We have, I don't know where this is from. It's Danish? Okay. We're selling an empty plastic bag. $10 going once. Do I hear 15 anywhere? $15? $10 going once? 15? Do I hear 20 over here? 25? Empty plastic bag. You can put your stuff in it, take it with you. 25 here. Do I hear 30? $30 going once? No, 35. 35. 40? Will you pay 40? Okay, 40. 45? 50? We can take credit cards. We can take credit cards. So it's 50 so far, right? From an empty plastic used bag. I want to be sure you know what you're buying, sir. Okay. So 50 going once. It is not signed. 50 going once. 50 going twice. Henning's shirt was in this. Okay. Sold. Thank you. So the only things that are left are the T-shirts. And to make sure that they're not confused with the other items, I'm going to put these over here. If you want one, come and get one. There's various sizes. But make sure that you give your money in to the people on the corner. John, give your money to John. And it's the honor system for all this stuff. I think that's everything. Does anyone recall any items that I haven't sold? No, I'm not selling this shirt. Not this one.
That's Duluth Trading, right?
Yes, it is. I'm very proud you noticed. It's got Leinenkugel on it. Sorry? Yeah, it is Leinenkugel. I didn't want to wear my Ron Burgundy shirt because it had the U.S. flag on it. I thought that would be in bad taste.
Okay, so one last announcement. The at the reception. Everybody gets 2 drinks per person, 2 drink tickets per person. There are for the vegan attendees, they have their, just ask your server for it. You can get your own plates, and you could use the slider and pasta stations. Allergies will be marked for each food station, and for, please, yeah. Say again?
And you can ask the server.
Yeah, you can ask the server. Sound good?
Cool. I'm going to be sitting over there to take your money and give you your T-shirts.
Sound good?
Sounds very nice.
Cool.
If you don't want your drink ticket, I'll hold it for you.